everyone. Good noon. Already I can see for our day two session, we already have a lot of people, and some people are okay. I can see a lot of people joining in now. Okay, cool. Let's give everybody, say, a couple of minutes to come in, settle down, and till then, I'm going to, for people who are joining us for the first time and couldn't join us yesterday, I'm going to give a little bit of an introduction of what we do in these sessions, who's going to take today's session, what are we going to cover, and all of that, right? So, yes, please tell the instructor to show Ayan is asking first, as due to an I logged out yesterday. Okay. So, Ayan, we are going to give you the link where we have the session hosted, yesterday's session hosted. So you can actually use that. So instead of, uh, you know, giving a lot of time today recapping, that link would be sufficient for you to just go ahead and follow along and do the session. You guys should be able to see my screen now, and I'm going to, yeah. I'm going to launch a poll also for people who joined in yesterday. I want to know how many of you could join us back today. Continuation is always great because we cover topics in such a way over these 2 days that you go from foundation, some concepts, and then till about like the final from demo to deployment sort of a journey. So in the first day, we covered foundations. For people who could not join yesterday, please do not fret. We will provide you the link of the recording. I would suggest for anybody asking, I think we keep getting questions on are we going to get recording or not. We will share the required links after. This is a live session, obviously. So once all of these sessions get over, we will give you the link, or your program advisor can give you the link. But I would highly suggest that you sit and make the most of these sessions. These are highly curated sessions, and you should make the most of it. Okay, so we covered foundations yesterday, basics of agentic AI. Then that was Parijat, who took us through the first session. He's back again for session 3 today, and he's going to take you through the multi-agent orchestration system. Session 2 was by Prateek, and he covered agents with MCP. So he showed you how to build your first, if it was your first AI agent, but using MCP on Claude, right? And the fourth session is going to be by Justin, who's going to join us from Ireland, and he's going to talk about how to take that particular multi-agent orchestration from demo to deployment and show you in production. Later on, you can look at the recording and follow along at your own pace. Okay. These were the free resources that were available with this particular launchpad. I will again post the links of our community, the Slack and Discord community, where you can join in and you keep getting such free resources and also updates about various other master classes that we keep doing every now and then. Okay. I will also post the link of our program expert so that if you want to, this is just a crash course of sorts, these 4 sessions, right, over the 2 days that we have done. But if you really are interested in taking a structured approach to upskilling and cracking those interviews, if you're serious about it, we are happy to help you and enroll you in our programs. So I'll also share the calendar link of our program expert. So just book a call at your own convenience. The session again, for some people already know, I repeated this yesterday twice, but for people who are joining us today for the first time, this session is particularly helpful if A, you're a tech professional, and if you're a tech professional in with any number of years, or any background, backend engineering or data or systems, or you are a engineering manager, right? It can be useful for you. If you have a tech background, you'll be able to relate to everything and most of what the instructors are saying. Little about interview kickstart. We started off about 12 years ago in Santa Clara in the US. And since then, we have been the go-to platform for AI upleveling, upskilling, and interview preparation for all the tech professionals out there, right? And why? Because of this, what I'm circling right now, because we don't treat every tech professionals as the same. We have about 18 tracks. So depending on what background you're from, if you would need a pro code, low code, or no code sort of track, we provide that also. So a backend engineer, a technical program manager, data scientist, an SRE DevOps guy would have very different tracks, not just for AI upskilling, but also for interview preparation, right? So because all both of these, because we believe in outcomes, and interview preparation is also a big part of helping you through or climb the career ladder. Our secret sauce is our Mang Plus instructors who are actually AI practitioners at the biggest of the names like Google, Amazon, Meta, Netflix, Microsoft. We have a couple of folks from Microsoft. We had them yesterday. Atlassian, all of these big names, right? We have had 27,000 plus students make the most of our courses across India and the US. So our quality standard in terms of teaching, in terms of updation of curriculum, everything is at par with what the industry is teaching. And these 700 plus Mang plus instructors, actually whatever they are doing in their day job, they directly pass that on to you over the weekends in our classes, right? You can see some of the success parameters that our learners have experienced, and we are very happy for them. And Yeah, this is about us. We obviously have been identified with by biggest of the names out there and awarded different awards. So this is about us. This was the secret sauce that I was saying. You are in for a treat because the two instructors who are going to teach you today are going to be a great sneak peek into the quality of instructors we have. Yesterday, I saw a lot of compliments for them in the chat, and I don't expect anything different today. I'm sure you guys are going to have great sessions. So, without further ado, I'm going to introduce Parijat again today. Parijat, welcome back for the third session. Thanks for taking the session one yesterday. Parijat, for people who could not join the session one, he's the lead data scientist at Microsoft. He's been there for 11 plus years. He's currently working on the Copilot project, and he knows everything AI, multi-agent AI. So I couldn't think of a better person to take this particular topic also today. So over to you, Parijat. And while I'm doing that, I'm just going to uh, sorry. Yeah, I'm going to launch a poll, folks. I want to know a little more about you because later in, I'm going to come in and talk about Interview Kickstart and our programs. And a lot of you actually booked a call with us yesterday. Our program experts calendar got filled. We are very happy to help you out there. So please go ahead and do that today also. I'll share all the links, necessary links in the chat. Any questions, please put it in the Q&A section. We have a subject matter expert, Abhinav, who is going to answer all of them real time so that Parijat can wholly and solely focus on teaching you the concepts. Okay, enjoy the session, guys. Have fun.
Thank you, Niyati, for introducing. Thank you for starting it up. So let me share my screen. Good afternoon, everyone. I see folks are trickling in. So let me share my screen and we can start. Um, So welcome to all of you to the third session of this AI Launchpad, right? I'm Parijat, as Niyati mentioned. So I had taken the first session yesterday where we talked majorly about the fundamentals of AI systems. We talked about basic RAG systems. We tried to have a small demo on a very basic RAG system. And we parallelly talked about multiple things around like why do we need to use RAGs, what are agents, right? How they are different from LLMs and so on. Okay. So today we'll talk more about the agentic AI orchestration side of things, where we look at multiple agents, right? So we don't look at one agent per se. We are looking at multiple agents now. So how the agents converse together, how the agents talk to each other, right? In what scenarios we would be using multi-agents and so on. So that's what we want to talk about today. Okay. So yeah, welcome to all of you. I see many folks from yesterday too joining in. That's great. So yeah, let's go into it. So we'll majorly talk about these few things, right? So we'll talk about like having a functional multi-agent system, like a team of agents coordinating workflows, right? And trying to solve a complex task where like multiple things doing multiple agents doing multiple parallel things, bringing them together, working on top of them, right? And so on. So how they communicate, how they talk to each other, how do you ensure that permissions are segregated, right? How do you ensure that these types of agents scale, right? So that is what we want to discuss today. Okay. As of yesterday, the first 45-50 minutes will be a bit around the conceptual side of things. The remaining half an hour time, the last half an hour will be on the demo side of things. Okay. So don't worry about the demo. We'll do it properly. We'll talk about it. We'll talk about a integration framework called Creo AI. Right. Creo AI is a way of like it gives us a good way of doing multi-agent systems, right? Writing code for multi-agent systems. And there are no code frameworks also, like say there are Init, Zapier, Minus. So there are multiple different types of no code frameworks also that you can use alongside say AWS Bedrock to at least build up the multi-agent scenarios and workflows and orchestration and such. Okay. So yeah, let's go into it. So this is the agenda for today's discussion. Okay. So we'll talk about when do we use multi-agent systems, uh, how does agent-to-agent communication happen, right? How do you plan and coordinate between agents, right? How does an orchestrator work, and so on. Then we'll talk about the environment, the memory, like how do you share memory? How do you keep some part of the memory to yourself based on the security and privacy laws, right? How do you ensure that you are monitoring things, right? How do you ensure that one agent is not doing something illegal or one agent is doing something unauthorized, right? And the other part of it is that, okay, if one agent is stuck, how do the other agents know about it, right? How do you scale? How do you ensure reliability and so on? Okay. Finally, we discuss the anti-patterns, like things we should not do, common pitfalls kind of things. And we'll look at the framework in terms of Creo AI at the end. Right. So this is the agenda for today's discussion. And so let's dive into. So we have 45 minutes for the theory parts and then half an hour for the code side of things, right? So we'll try to keep this balance. This is a 1.5 hour session till 1:30, so we won't have any breaks in between. Okay, it will be quite fast paced, so I'll request all of you to be attentive. Right, put your questions in the chat. Abhinav is here to help you out from the Q&A side of things. Right, if you have any questions, doubts, right, feel free to put it in so that like you get real time support, real time answers, and you can follow with me. Right, so that will basically be the best way to move forward on this. Okay. So let's go into multi-agent parts, like when should we use multi-agent systems, right? So obviously the first thing that you can think of when we are talking about deciding single agent versus multi-agent things is uh, understanding the complexity of the work, right? So if you are doing something reasonably complex where you need diverse skills, right, or long reasoning chains, so in those cases, you will always go with multi-agent systems. If you need something to be happen in parallel, right? So two agents can do it in parallel, definitely go for multi-agent systems. If you need any kind of like say if you see that there needs to have to be some kind of cross verification, right, some kind of resilience, so in those cases you would need multi-agent systems to actually build that resilience into your product, right? And if you don't need any extra agents, if things are all sequential, right, if things are there are not a lot of permission issues, like by that I mean that different agents work with the same set of like different tasks can be done with the same set of permissions. You don't need performance segregation or role-based access control as such. Then you can go with single agent workflows themselves. Okay, so that is the difference between multi-agent and single agent workflows, right? In terms of the ROI versus complexity, so obviously it's a trade-off, right, as to what you get in terms of your investment and what is the complexity of the work, right? So if you see that things are reasonably complex, right, so multi-agent systems will excel on large open-ended problems, but they will also have overhead costs, right, because there are multiple agents, they are talking to each other. So we generally spend like around 15x more tokens. Okay, so we spend like than single agent approaches, so which is a huge cost over it, right? We try to justify it by value if we find that our multi-agent systems are bringing us back that kind of return on investment, right? And finally, we think of the scenarios when it is not a fit, right? So if it's a tightly coupled scenario, or if it's a sequential task, right, that doesn't really need multiple agents, then in those cases, you will just go with a single agent workflow, right? And it will directly build up. So multi-agent workflow is not a fit there. Okay. When should you not use multi-agent systems? So if you think that you are doing over engineering, right? So there is a trivial task and you are breaking it up into many parts, no need to do it, right? If you see that if you are trying to do, like, if there are a lot of chatty loops, right, which means like a lot of communication between the agents are required, right? In those cases, again, no point of doing multi-agent systems. Okay. If there is a plan drift, right? So which means like if you're a multi-agent plan veers off topic without a clear goal owner, right? So in those cases, again, no point of doing multi-agent systems. And finally, if you have like unbounded retries, right? If there is no stop condition, or there might be a chance of infinite loops or hallucination, in those cases, try to avoid multi-agent systems, because multi-agent systems, if they get stuck in a loop, right? Lot of communication will happen, lot of looping will happen internally, and they don't give any ROI, right? No return on investment, uh, like lot of cost involved, right? So in those cases, you don't go with multi-agent systems altogether. Okay. So that is about the when to use versus when not to use these types of things, right? So once you justify why we need to use more than an agent, right, then we go into understanding how they communicate and coordinate with each other, right? And for that, we'll go deeper into it. So we say that, okay, we'll talk about the agent to agent communication. That is the section 2 of what we wanted to discuss, right? So now we know when should we use multi-agent systems, when we should not use, and when we should use, then we have to think about communication between them, right? So we have to look at. So, in terms of, like, say, communication protocols, like there are different types of ways, or there are different ways rather, in which IT agents or different agents can communicate with each other, right? The first type of way that we can do, or that actually works, is essentially around using, say, standard schema, right? Having a structured schema, having a JSON message, right, with fields like, say, the type, the content, the to and from, and so on. So that's a very good way of doing things, right? Then you have more complex ways of doing it, right? Say, like, you can have the intent, like, okay, who is sending the message, what is the message being sent, and so on. So what is the intent, what is the context, what is the relevance, and so on. And then we have the provenance aspects, right? Provenance meaning, like, we tag the message with every sender ID, the conversation ID, the task ID kind of things, and the traceability aspects, right? So these are the, like, three to four different ways that are there, right? So we generally talk about these types of ways in which messages are sent or received, right, between agents. Okay, so it can either be in a JSON format, it can either be in a provenance format, right, where you give the sender ID, the receiver ID, the task ID kind of things, and you move forward with this. Okay, so that is what the conversation techniques are, right? So these kinds of techniques basically help agents understand this. So the moment you bring everything into a common schema, it helps agents understand, okay, why things are happening in the way that they are happening, right? So what is the, like, what does the message tell, right? Who is the message from? What is the intent of the message, right? Is there a task associated to the message or not, and so on, right? So we have these kinds of things. Okay. Right. So that brings us back to the next part of things, which is communication patterns. Okay, so communication patterns are different from message schema, right? So we talked about message schema in terms of, like, say, the end-to-end communication between agents, but now we talk about how, like, the agents are structured, right? Where the agents are and how the communication happens, right? So the message structure basically shows the protocol in which the messages are sent, right? That's what we talked about. But now we talk about the communication patterns. Okay. So the communication patterns are very similar to engineering communication patterns. So we can have a hub and spoke kind of a model where, like, it's like a one to many kind of a framework where one agent sits in between, in the middle, and then it talks to multi agents, right? You can have a blackboard model where it's like a shared memory where one agent writes logs there and the other agent reads from there, right? It's a shared blackboard. You can have a pub-sub kind of a model like a messaging queue, which is used for asynchronous communication. So one agent publishes, the other agent, based on the listener, when it is free, it will listen to it, right? Look in the channel and get back the message object from there. Right. And finally, there's a group chat, right? So all agents are there in one thread, and there is a coordinator or a supervisor who is coordinating all the agents and how they are talking to each other. Okay. So these are the four important techniques in which you should be working with it, right? So in terms of which schema you should be using, it always depends on the use case that you are going into, right? So if you have to go into a one-to-many use case, then you will have to think about a hub and spoke model, right? If you have to think of a sequential use case, then generally we go with a blackboard model where one agent posts, other agents look at it, the next agent posts, and so on, right? It's a blackboard model. If you go for an asynchronous use case, then PubSub works, right? And so on. Okay. So each use case, like as you go forward, as you explore agents more, right? I think most of you are like many of you are beginners, right? So as you explore more and more agents and more scenarios, it will become automatically clear, oh, that for this scenario, I'll be using this type of pattern and so on. Right. So that definitely the experience in with agents and experience in using and building agentic workflows definitely helps identify the right communication pattern that you want to go with. Okay. Makes sense. Then you have the turn taking and handoff scenarios, right? So you have turn-based dialogues, like say enforcing order for agent turns, right? So how do you ensure that the agents are respecting turns, right, or they are not behaving haphazardly and so on? So we try to do it by say enforcing order for turns of agents, right? We call them the turn-based dialogues. Sometimes it can be a role handoff while one agent is answering something or trying out something, and then it will hand off to the next agent, right? It will hand off to the next agent, and it will give opportunity to the next agent to talk about it or write about it, and so on, right? And the third thing is having the conversation context, right? So you maintain a shared thread so that all agents can see the history of the turns, right? History of the use cases and so on. And based on that, the agent takes up the next best possible use case that you need to do, right? So each agent have their own conversation contexts, and there's a shared conversation context. Each agent answers there, puts their answer there, puts the log there, and all other agents can see the conversation context, right? The shared whiteboard or blackboard kind of a model. Okay. So these are different ways, or these are different protocols in which the agents can talk to each other. And so we talked about the message communication techniques, the protocols, right? And basically the house, right? In terms of the patterns in which agents talk to each other. Okay. And obviously, at the end of the day, you have to have an orchestrator, right? Without an orchestrator, things generally fall apart. So you have to have an orchestrator around which is the next agent that should talk, or if there is a conflict between two agents, we should get more preference, right? And so on. So the arbitrator decision making or the orchestrator decision making is super important. And based on that, based on, say, some kind of majority voting, or if there is no consensus, or if there is a tie, then it might notify the human agent, right, to be able to give the decision and so on. So those kinds of tie break logic, voting protocols, and all these things, or order maintenance and so on, are handled by the orchestrator, right? So that orchestration is known as the arbitration and conflict resolution step, right, where the arbiter agent is it designates a moderator or a judge to resolve the conflicting answers. Okay, so that is what is all about the arbitration aspects. Then we have the error channels and retries, right? So when do you retry? When do you know that there is a problem, right? So when you see that some agent has not been like answering for some time, so you use a timeout, right? So that is the third one. Timeouts are super important to have. So you should have a shared clock or a shared timeout that actually tells that, okay, by when did you expect the response? And if the agent has not responded by then you stop expecting and go to a fallback, right? So that is the fourth one. So when some agent times out or some agent is inoperative, right, then you go to a fallback. Okay. On repeated failure, you trigger specialized error handler agents and human in the loop side of things to be able to go deeper into it, right? Then you have the dead letter queue. So if there are unhandled requests, like generally this happens in an async use case. So if there are if there are like say unhandled requests or failures that are there, then you go to the DL queue, right? And if there is say some kind of a failure, we'll not immediately try, right? Retry. So we'll have backup retries, which means we try the first trial happens say after 2 seconds, the second one happens say after 5 seconds, the third one maybe after 20 seconds. So we are backing off as we move forward, right? So that's what we try to do as we move forward, right? So these are the four ways in which we handle errors, we handle retries, right? We try to ensure resiliency. Okay. So these are different ways in which we are trying to handle the resiliency side of things. So now we have the basic things in place, right? We have basic things in place. So we want to design the plans. We want to design the memory, right? The roles that we want to use to keep the agents aligned and so on, right? So for doing that, now we'll talk about the planning and the coordination steps. Okay. So in terms of planning and coordination, it is again very simple and the things are derived from like basic engineering stuff only, right? So we have local versus global planning, right? So for example, we have a global planner agent or a dedicated planner agent, which breaks the task into multiple pieces, right? Assigns agents into one of the tasks, understands which are serial, which are parallel, and so on, right? So that is the global planner. Then we have the hierarchical planning steps, right? So hierarchical planning means you have worker agents. The supervisor basically offloads or kind of delegates some of the work to the worker agents. You consolidate the result and then finally it gives it back, right? It passes the thing back. So that is known as the hierarchical workflows. And finally, you have the single leader model, right? The single leader model essentially helps you like avoid multiple planners to avoid any kind of conflicts, right? So there is only one leader, there are no multiple leaders, and whatever the one leader decides in terms of, say, scheduling or conflict resolution and so on, that only holds. Okay. So yeah. So that is the global versus the local planning parts in terms of figuring out how the agents work together, right? And so on. Okay. In terms of delegation and negotiation, so like agents will pass subtasks to the best suited peer, right? Sometimes it is the available agent, sometimes it is the specialized agent, right? There is often negotiation as to like agent might say that, oh, I can do this task better, so can I take this one and so on. So there is negotiation between the leader and the follower agents, right? We build codes around that. There are self-verification steps. So agents will double check based on their chain of thought or based on their React-based processes, right? Saying that, okay, this is what I got. Is this answer correct, right? Is this answer factually correct? Is this answer relevant to whatever the user asked and so on, right? And finally, the dynamic reallocation. So if an agent is dynamically like if they are stuck, right? So overloaded or stuck. So how do you assign the task to any other agent or how do you split the task, right? To ensure maximum reliability. So those things are also taken care of by the delegation and negotiation skills. right? So then the next part comes into the stock conditions, the budgets, right? So what are the token budgets? How much token budget do you have? How much time budget do you have? So if you have token budgets, then you don't do a lot of communication, right? You try to use single agents. If you have stock conditions, or if you have time based things, right, you will try to do as much as synchronous things as possible, right, and so on. If you have, like, say, if you want to have a kill switch, right, we try to build an orchestrator that can abort entire agents, right? So sometime it might go off track, or agents might go like hallucinate and so on, right? So all these things we need to build, because agents at the crux of themselves, they are not deterministic, right? They are probabilistic, so they can behave in any random way. So we try to prevent all those kinds of issues. We try to preempt all those kinds of issues as much as possible, right? So that is the stock conditions and budgeting side of things, right? So that is this is again, this is super important, right? And yeah, so and then we have the human in the loop checkpoints, right? In terms of human in the loop checkpoints, we try to mean that whether you want to have a planned pause or not, right? Whether you want to have an audit gate or not, right? To understand, oh, this is a very very important point where you should stop and ask ask the human in the loop that, okay, is this going in the right track, right? Or you need some kind of like secure authentication, or 2FA or MFA kind of a step, right? Multi-factor authentication, where the human has to step into, right? Say some complex operation you are going to perform in the database. So for that, you need an explicit permission from a human being or from the on-call engineer, right, to do that. So all those kinds of things you would need to do escalation. You would need to have planned pauses and so on, right? So human approvals are super important to go deeper. Okay. Right? So we'll try to define the shared context. We'll try to now define the per agent memory, right? And how the agents read write over it, right? So we have to think about agents as a state machine, right? So there is a shared memory somewhere. Some agents will take a look at the shared memory for some tasks, and they will look at their own memory for some other tasks, right? So each agent will have a local memory, and all the agents together will have a global memory. Okay, and that's how we call themselves a local memory, global memory, episodic memory, and so on. And that's what we'll now talk into. Okay. So the in terms of the world state, right, the shared memory and global memory side of things, uh, like again, very similar to engineering, right? So shared context stores are those where we want to store the global states, right, which should be accessible to all agents, right? Whenever we want to have, like, say, some kind of a state which can be read by, say, agents, which can be read by say normal programs, right, we use the shared context stores, right? If you want any kind of synchronization between agents, right, no agent will miss the updates if you put everything in a global storage, right? So that's where we use it. And then on the other hand, we'll try to have a local storage also, right? So each agent will have some things which other agents don't need to know, right? Say some config steps, some passwords, some secrets, right? So for those, they will have a private short-term memory also, which will be relevant only to that particular agent, right? And we'll try to have like time to live, or like cleaner segment kind of things, which will basically cron jobs kind of stuff, which will run and clean those memories after some time, right? After maybe, say, some TTL, right? So then they will reset the TTL so that, like, the major memory is not overflowing, right? At the same time, the agent are storing the context, agent are being able to understand context and so on, right? So that's what we'll try to do. Okay. So that is pretty much it in terms of the memory side of things. And yeah, I think this we had already discussed yesterday, right, in terms of a rack system. So we say that, okay, if the rack system is enough, right, we can give the answer back and we generate the response. If it is not enough, then we do some kind of other action, right? And this is where, like, other types of agents can work, right? So you can have, like, say, a Tavily kind of an agent which does a search online, right? Or you can have a Google API agent which does a search online and gives back the answer, right? So if your database doesn't have that information, if your vector DB or your knowledge base does not have that information, you can always spawn another agent which looks for that information in some other place and brings back the response, right? Finally, you do the generation at one place, right? So these types of flowchart, these types of complex workflows, you can try to build with the agentic systems. right? So that is what we try to build. And yeah, and then comes the reproducibility part, right? So reproducibility is essentially, it means that I already talked about it. So since agents are stochastic in nature, right, they are not deterministic in nature, right, they are probabilistic. So one time you give a question, it might answer something, next time you tell something to do, it might answer differently, right? So for that you have to ensure how do you make it as deterministic as possible, right? You should put checkpoints, you should put explicit prompts, right? You should say that okay, this you should do exactly once, if you find this then only you go to the next step, and so on. So agent should not be hallucinating at all, right? Try to avoid any kind of external side effects, meaning say some external API you called, you did not get a good response, how does the agent work on it, right, and so on. So those kinds of things you should work with as much as possible. Okay. So yeah, similar agents can be used for like say different solutions, right? Provided they are deterministic, right? Provided they are like you are able to get a like a correct response, say 99% of the times or even 100% of the times, right? You get the same response by making your prompt more detailed, by making your checkpointing and human in the loop more instantiated and so on, right? More clarifying those individual things. Okay. Right. So now we have the basic stuff up, we have the memory up, and right, we now know how agents are communicating with each other. Now we'll talk about the permission side of things. Right? Permissions are super important because like you would not want to give the UI agent permission for the database, right? You wouldn't want the database agent permission for the say the service, right? So you want things to have as siloed permissions as possible, as much as uh, less scoped permission as possible, right? So you that particular agent can do only one task, right? For any other task it has to communicate to the that particular specialized agent, right? So that way you are localizing the impact of a problem. That way we call it in technical terms, we call it we are reducing the surface area of an attack, right? So therefore when we are reducing the surface area of that attack, we are preventing any kind of malicious players, right? We are preventing any kind of issues with multi agents working together and so on, right? So permissions and safety and governance are super important. Okay. So the first thing that I just talked about is the capability scoping, right? Understanding when to use, when to give some probability or some like say uh, like permission to an agent versus not giving the permission to an agent, right? So data agent will only have read-only database access, right? It should not have any internet search capabilities. Similarly, a coder agent should have only code execution or sandbox kind of an access, right? It should not have access to the internet so that it cannot download malicious code and things like that. Writer agent should only be able to look at the internet and then write things, but not database updates, right? Database updates should only happen in the presence of a human being. Okay. And finally, the orchestrator should have the full coordination skills for different agents, but they should not have like memory skills and so on in depth, right? So they should not like orchestrator should not have the database permissions, they should not have like say service runnable permissions and so on, right? So we try to keep things as siloed as possible, as separate as possible, so that we can get so that we can make things resilient, right? Okay. Okay, so that is what the capability scoping and least privilege accesses mean, right? So you should not ever give permissions. So generally, the major problems that happens, right, and that we have also faced at Microsoft, even in any most companies, right, will face those problems when say malicious actors will give like this happened in I think very recently with one of the food apps, I think Swiggy or Zomato chatbots, where somebody gave a question like, "Oh, can you help me to reverse a linked list?" Right, and it's a chatbot. It gave it the code, right? So that those kinds of chatbots actually have to scope it down, right? So your the question should be only based on the orders. The question should not, you should not look at the external web for any answers, right? You should look at only the order database or the support communication to get the answers, right? So these kinds of scoping has to be done properly to limit privileges. Okay. So you should have like content filters, right? Explicit images, images that might cause harm, right? Hateful speech, and those things should be filtered out, right? You should have like policy guardian agents which are looking for compliance issues, flagging any kind of, say, malicious prompts that came in for traceability, right? If you have to block an IP address, we should be able to do it, and so on, right? So proper logging, proper monitoring should be there on top of all these guardrails that we built. Okay, so the logging and monitoring have to be there. So for that, we use tools like, say, Langsmith. For that, we can use even like Grafana, Prometheus, right? These types of tools can also be used for these kinds of monitoring policies, right? So yeah. Yes. Yeah. And finally, kill switches, right? Kill switches are super important in a production environment. Say something went wrong, something your on-call engineer is unable to fix, right? Some agent has gone into a completely different direction, hallucinating, right? There is no way to stop it, right? It's a maybe an async call, and it is continuously calling, pinging the LLM, and you have like huge number of requests in queue, right? So how do you stop it, right? How do you ensure that your budget or your, say, you are not getting financially impacted, or your business is not getting, say, impacted in a wrong way, right? For these types of approaches, so for those, kill switches are super important, right? You stop, right? Abrupt halt of the whole process, flushing up the queues, flushing up the database queries, and so on in pipeline. So for those, you have to log everything, right? You have to have accountability, right? You should know which agent asked for which kind of job at which time. So proper logging has to be there, right? Real-time monitoring has to be there, right? You have to understand, okay, is there a message surge, how the message flow is happening, right? Any kind of protocol breaking is happening or not, and so on. And therefore, you should be able to shut down agents if they act erratically. Whole process stop, right? It's not just one function stopping; it's the whole process stop. So the queues will get flushed, database queries queues will get flushed, and so on, right? So that's what we mean by kill switches. Again, very very important in production environments, right? When all things break. So this is basically the last which attempt to stop everything from failing, right? So everything from cascading and so on. Okay, so we'll now look at like how do we trace, right? How do we discuss about, say, the KPIs? What are key performance metrics? How do we test things out, and so on, right? So that is the next part, and we discuss about the observability and the monitoring aspects, right? So I think, yeah, there are multiple questions about demos. So as I mentioned in the beginning, I think folks might be late for joining and miss that part. So we'll have the demo. We'll have it from 1 to 1:30, right? The last half an hour we have reserved for the demo with Crew AI. And that's where like without the like understanding the fundamentals, it's very difficult to go into the demo, right? Because like these are super important, because when you go into the industry, AI can write code for you, right? So you will not be writing a lot of code, right? You have to ensure that you understand these fundamentals, understand, say, threading, understand security, compliance, risk, right? How does multi-agent frameworks communicate, and so on. And that's where like covering these or understanding these are like very very important and pivotal. Okay, so that's where we are taking more time to cover these, and then we'll go into the demo side of things, right? So yeah, in terms of tracing, right, coming back. So in terms of tracing, you should have unique trace IDs, right? One process should have one maybe major trace ID and then multiple minor trace IDs for the functions, right? You should design it accordingly. You should have span logging, right? Span logging meaning each step, what are the things happening, should have similar logs, right? You should have a causality tree saying that, okay, because I did this, I am doing this, right? So you should have the cause and effect kind of chains and so on, right? So these are super important to have a tree of agent calls, understanding like, okay, where the calls went, right? How one agent's output leads to another agent's actions, and so on, right? So those are super super important to go deeper into it, right? So these are the key metrics that we generally look at. Okay, so we talk about average steps per task, the success rates, right? The latency, if you are stuck or not, right? How many times are you stuck, right? What is the stuck loop rate, and so on. Okay. So some are of the positive ways, as you can see, like average steps per task should be as less as possible. Success rate should be as high as possible, right? Latency should be as low as possible. Uh, Stuck loop rate should be as less as possible, and so on, right? And then we have, like, say, the evaluation harness and testing skills, right? So you should be able to write tests properly, right? Tests can be very basic, like, say, scenario based tests, right? So each agent, if you want to see whether they are performing well or not, you have scenario tests. If you want to see whether multi-agent workflows, they are communicating properly or not, right? Try to have like continuous integration kind of things, right? Where like multiple agents are working together to get an output, right? Try to have like the ground truths. What is the golden expected output, right? Where you are, and what is the regression, right? Where you reached, where you came back, what is the regression happening, and so on. So those kinds of things are super important. And then you try to test with complex corner cases, right? So what are the tricky situations? What are ambiguous instructions, and so on? Okay. Right? So understanding the evaluation harnesses, understanding what type of text we try to do, and so on. So those are super important to go deeper into it, right? So that is mostly it. And now we have the visibility, we have the monitoring, right? Now we have to think about the scale side of things. So if you go into a product company, you are generally probed into the scale aspects of any agentic AI system, right? You are building things, but then when you have millions of requests flowing in, how do you do scale, right? How do you ensure that scale is happening properly, right? So in those cases, the concurrency, isolation concepts come into play, right? How agents can work in parallel. If there is a blocker, if there is something, somebody is stuck in a loop, right? How do you isolate the agent, right? How do you ensure that the crashes are not cascading, right? So that is known as crash resilience kind of thing, right? How do you know that if there are like whether you are overloaded or not, if your queues are full or not, right? How do you shed your load, right? So all these kinds of things you have to ensure that you know and think about and build your design accordingly, right? So that is all about the scale and the resiliency aspects of a multi-agent system, right? So you have to think about how it can cater to millions of requests, and you have to think about how it responds to failures, right? Does it shut down altogether, or or are you able to isolate the particular failed part, and then you are trying to build up around it, right? So that is super important in terms of the process isolation and parallel execution scenarios. Okay. So yeah. So about that. So then we talk about the recovery strategies, right? So how do you recover? Do you start from the beginning? No, obviously, right? So you have to checkpoint. So you have to decide where you should checkpoint, right? You should figure out how you should resume from the checkpoint, and so on, right? Secondly, you should think about how do you ensure that the site any kind of side effects that happened, right, due to some failures, that are minimized, right? How do you roll back, how do you correct things, and so on. Okay. And finally, how you gracefully degrade, right? So if a subagent fails, how do you run a partial results with a note that, okay, the system is running partial results, rather than like you are trying to have the checkpoints properly, you are trying to retry properly, something failed, you are not falling back to the beginning, right? You are falling back to the m- most recent meaningful checkpoint, and so on, right? So these kinds of things we have to work on it. Okay. So yeah, right. And then you have to think about the cost also, right? So there was a question in chat like as to how do you optimize prompts, right? Or how do you optimize, say, multi-agent workflows? How do you optimize the token budgets, right? So you have to think about cost control, right? You have to think about how do you ensure that, like, how do you use cheaper or smaller LLMs, like, or SLMs, without hampering your model accuracy, right? For less critical jobs, you can use those kinds of low cost LLMs, right? You can try to use a key value cache, right? For factual answers, you can put them into the key value cache and you can directly get the responses from the cache instead of directly querying the LLM, right? That way you can save a lot of tokens. You can try to do batches, right? So multiple similar requests from multiple tokens can be batched into one API call so that you can reduce costs, right? And then obviously you have to have human budget enforcers, right? You have to monitor cumulative budget, right? Have some kind of a dashboard which shows in real time what is the amount spent per day, right? Or in the last 1 hour, so that you can monitor for surges, right? You can prevent any kind of, like, say, agents that went rogue, right? Or hallucinated, right? Or like, say you are just going over budget, or you have consumed, say, 50% of the monthly budget, then you should alert the right people, right? And so on. So you should not leave anything up to fate, right? You should ensure that the checks and balances are kept into play so that you can go about and build a real workflow that your say clients or customers will really use, right? So that is the aim of learning all these individual things in detail. Okay. Makes sense. So yeah. So now that we know, like, what good means, right? So it means memory, it means resiliency, it means scale, it means correctness, right? So now we will try to think about frameworks, right? So what type of frameworks we can use, right? So there are two major types of frameworks. So one are the no code frameworks that we talk about. So Zapier, Init, Make, right. So these types of frameworks actually can help you build multi-agent systems. These are drop and like drag and drop kind of systems. So you can easily work with these, right, without any code background. Okay. If you know the concepts, if you know the services that you want to use and so on, you can just drag and drop, play with them, right? Get the API keys, call them, and so on. You will have monitoring dashboards, observability dashboards, and all these things together in one place. So no code automation frameworks definitely help you build up the canvas and work with, like, say, even for non-developers, it gives a good platform to work and build multi-agent systems. Okay. Great. In terms of the agentic side of things, so these are like some examples of no code frameworks. You can see these are like drag and drop, like, code spaces, right? You don't have to write code for them, but internally code is there in the form of JSON, and then converted into basic uh, like Java or Python code internally, which externally you are just dragging dropping things. Okay. No code frameworks, just to give up like a last bit of it, no code frameworks also help you with that, a lot of templates. So all these companies coming in, say Swiggy has their own MCP nowadays, Outlook, Teams have their own MCP servers, right? So they give a lot of templates which you can directly use, right? Drag and drop and directly use them. Okay. And code-based frameworks like, say, Langsmith, chat prompt templates, right? These actually help you in more fine-tuning, right? Going deeper into, say, like having more control on the code, right? Maximum flexibility kind of things you can expect from the code-based frameworks. So LangGraph, Langsmith, these are used. LangGraph is used for multi-agent systems. Langsmith is used for evaluation and observability, and so on, right? So you can see here, LangGraph is used for allowing agents to define the shared state, creating nodes for different actions, right? Connecting the nodes with edges, conditional edges, and so on. Okay. So these are LangGraph codes that you can see, right? So we are using, say, LangGraph is majorly used for communication between agents, right? So you can see here graph builder, add node, add edge kind of things, which means the agents are being connected together by these kinds of graph nodes. Okay. And then the coming to the demo side of things, so we want to spend the remaining time on Creo AI, which gives us the best of both worlds, right? It has a no code and interface also. It has a code based interface also, right? So we'll look at the code based interface today in terms of Creo AI, and we'll try to see how, like, different, say, pieces are there, how they are working together to get like to build a multi-agent system. Okay. So this is what we'll look at. Yeah, and finally, the real world use cases, right? Where do you use multi-agent systems? Everywhere, to be honest, right? So finding out patient healthcare summaries, reports, right? Aggregating different things into one place, sending mails to doctors around heads up around patients, right? Existing patient history, all these things, use cases can be worked together, right? And they can be used in healthcare, right? Similarly, you can use them in financial services to say figure out frauds, figure out and prevent frauds, right? Figure out frauds and then try to see whether they were actually genuine things or not, right? Whether they were false positives, true negatives, and such, right? So all these complex workflows, you can use any kind of these no code or low code frameworks to combine agents to do the work, right? And obviously in manufacturing, right, multiple say production houses, multiple production lines, multiple tools doing different parts of the production, how do you bring them together, how do you work with them together? So those things are important from a manufacturing perspective. Okay, so now specifically we'll talk about, as I was mentioning, one particular framework, right, that is called Creo AI. So Creo, as the name suggests, it's a collaborative group of agents working together, right? So for multi-agent workflows, Creo AI is one of the best possible tools that are available in the market, right? There are obviously parallels, so you can use LangGraphs and all, but QI gives you a good balance between like code and no code frameworks. Okay, so it's open source. It's a multi-agent orchestration framework. Okay, and it shifts the paradigm from prompting in a single LLM to managing a specialized team where autonomous agents assume distinct roles. They will share goals, right? They will pass tasks among themselves like a high-functioning human workspace and workforce and so on, right? So that is what Creo AI does. And in terms of the Creo AI aspects, right? So you think of an agent as a specialized worker, right? So you define its role, you define the goal, you define the backstory, and so on. Then there are tasks, right? Capabilities given to the agents to interact with the physical or the digital world, right? That is what the tasks are. So these can range from, say, file reading to more complex things like, say, custom APIs, full MCP servers, and executing sandbox codes, and so on, right? And finally, the Creo is essentially nothing but the orchestration layer, right? That brings all the agents and tasks together, right? Defining how they will collaborate, how they will communicate, and so on. Okay. So Creo AI essentially is the orchestration framework between the agents. That's what we'll look at now, right? So this is what we'll try to build in code, right? We'll have a integrated content management workflow, right? So we'll have an agent which does a research, right? So we give a topic, the user gives a topic, the researcher agent basically does a research on that particular topic. The writer agent writes a comprehensive blog piece about the topic, right? And finally, there is a summarize agent, which basically it's a social media summarizer, which takes the essay, converts it into a social media post, adds relevant hashtags, right? And finally, it publishes it to the right social media under your handle. Okay, so this is the use case that we'll demo in Creo AI and we'll look at. So for folks who are looking at, like, we're expecting code, right? So this is what we are trying to do, right? And we'll spend the remaining half hour on this. Yeah. So one agent will be doing the research, the next agent will be doing the writing, and the third agent will be doing the summarizing aspect, right? So this is kind of the preview, right? So you have the preview, I'll show the notebook workflow, right? So the purpose we already discussed. So we'll try to have three agents, right? So one will research the topic, one will generate the content, and one will write the social media post, and finally we'll post it on a blog, right? We'll talk about the sessions and dependencies, right? For the sessions and dependencies, we need to have the libraries, right? We'll show the libraries with Creo AI and OpenAI Key. Okay. The common libraries, the other things that you need to use is LangChain, right? And Chat OpenAI for the LLM capabilities. And finally, we'll have the agent tools, right? We'll show the researcher agent, writer agent, and social media strategist agents, and then the tasks that happen, right? So let's go into the code side of things, and let's see how the demo looks like in terms of this flowchart, right? So we'll have the setup, we'll have the helper functions, the agents which use the helper functions, right? The tasks which use the agents, and finally the crew which use the tasks and the agents together, right? So that's what we'll look at. So let me just open it up. I hope my code screen is visible to everyone. Right? So yeah, we are just installing things, right? So the only paid thing that we'll use here is the OpenAI part, the LLM capabilities, right? That also, if you want to use an SLM or you want to use something for free for a cheaper LLM, you can go for it, right? But OpenAI API keys are also pretty cheap. I think the basic recharge is of $5, which you can definitely use for demos and testing things out and so on, right? So that should be good enough for the basic one-time cost hit. Okay. So these are the install steps. So we are installing the OpenAI libraries. We are installing the transformers, right? We are installing the Creo AI tools and so on. Right. So we are giving the minimum versions that we want to use, right? That is the pip install steps. If you use, like say, Jupyter Notebook locally or in Anaconda, you can also create an environment locally, and then you can use Conda, right, instead of pip to install stuff. Either is fine. Since we are using a Google Colab notebook, we are using the pip function here. Okay. Now we do the core imports, right? We have the core imports in terms of the OpenAI keys and everything. So you can see I'm trying to do a get password and get the OpenAI key, right? If you want to see where we are getting the OpenAI key from, so you can go to the OpenAI dashboard in API keys, right? So this is the OpenAI platform. You can go to API keys, right? And you can create a new secret key kind of thing, right? And it will tell me the monthly spend, how much of total credits I'm left with, and so on, right? So this is my test account, and this has that $5 this thing, right? Which I have currently a credit balance, as you can see, of almost $3 now, right? And this I use for demos and so on. So this is what we have. Okay. For Creo AI, you don't need to pay, right? This is an open source framework. Okay, it's a multi-agent platform which is majorly open source. Some parts of enterprise capabilities are like say scale, and some specific communication protocols are paid. Okay. For your demo or for like your usage of Creo AI, just to understand its functionalities and so on, you should be using the free version itself, right? Which is available open source in Python as a library, right? And you will be able to move forward with it, right? So you don't need to pay for anything apart from the small OpenAI subscription. Okay, that also you can make it free by looking at other LLMs which are like lower cost or even free. Okay, like Phi, Llama, SLMs, and so on. then we have some of the implementations, right? Some of the helper functions. So helper functions meaning like how do we make a social media copy, right? How do we post the social media feed into say our LinkedIn or into our Instagram using the LinkedIn API, right? Using the right APIs and so on. So these are helper functions. So these are postfixed by, you can see suffixed by IMPL, right? These are the implementation functions, the helpers. So there are two helper functions here. Let me just show them to you. Yeah, these are the two functions here, right? So the first helper function, that is the make social media copy implementation, that we are saying that the platform string by default is LinkedIn, and we are saying that prompt is like craft a concise, uh, depending on the platform, post prompting and promoting an article, right? The title is whatever the user gives, the summary is whatever we get from the LM, right? And constraints are like it has to have one to two punchy lines, right? Because it's for a social media post, so it has to have one to two punchy lines, some clear CTA, right? And 3 to 5 relevant hashtags. Okay, so based on the text, based on the topic, based on the platform, this kind of an implementation is creating a social media post, right? Which gives you that idea, right? So this is the implementation function for the social media copy, right? And then you have the post via webhook implementation, right? So this basically, the second part to it is basically once you create the social media post, you have to post it, right? So for that you can use your social media URL, right? So if you say want to post it in Twitter, you can log into Twitter, you can get a Twitter key, or if you log into LinkedIn, you can get an API key from LinkedIn and you can use that here as a webhook, right? So when you say post in that API address, so webhook will get that, sorry, LinkedIn will get that webhook callback, function callback, and then basically function call and rather post it and give you a callback of a success or a failure, right? That the post succeeded or post failed kind of thing. So these are the two implementation functions that we have. As you can see, there is less code here. There is more about the description, right, around what we want to do. And the main major code here is this prompt, right, that we have that we want to pass to the LLM, that we pass to the OpenAI, right? And here we have the post part, right, in terms of whether the person posted or not, that is being verified. Yeah. Now the tools, right? In terms of the tools, we have the make social media copy tool and the post API, the post via webhook tool, right? So these are the base tools, right? These are basically, this gives you a idea about the description, right? So if you say to your agent that, oh, I want to post something to my Facebook, right? But here you have done only work on LinkedIn, or you have given work on say any placeholder social media, right? How does the agent know that, okay, that has to be replaced by LinkedIn, right? It has to be replaced by Facebook, right? How does it know it? So for that, we can use like the tools, right? So the tools will essentially work as the title and the description of the task themselves, right? Along with the run function, like what they want to do at the end of the day, right? So you have the title, you have the description, right? And you have the final run function, which is the work that they are trying to do, right? So now when we have these types of tools available, so now we can actually work with the like we can now start building the agents, right? So we'll have three agents because this is a multi-agent workflow. We'll try to have three agents. Okay. So one is the researcher agent, the writer agent, and the social media agent. Okay. The social strategist agent. So we'll define those three agents first. And for each of the agents, we'll hook up with the right set of tools that they have, right? So this is how we are trying to create the agents, right? These are the agents here. You can see the researcher tool, right? You can see the researcher agent, right? The role is a researcher. Goal is to collect 5 up-to-date credible insights on the topic, right? So 5 bullet points. A backstory is finds and synthesizes resources, right? Allowed delegation is false, which means they have to do the task. They cannot delegate the task to someone else, right? Similarly, you have the writer agent, right? It's a senior technical writer role. Drafts a 600 to 900 word article from notes. So 5 bullet points that it gets. With that, it can create a 600 to 900 point essay, right? And finally, you have the social media tool, a social media agent, right? Which basically looks at it creates an article into a platform optimized post, right? Optionally, it can also publish based on its webhook, right? To LinkedIn, to Instagram, depending on the API calls and everything that we pass to it in the parameters. Okay. Right? So this is the social media tool. These are the 3 tools that are there, right? And once we run this, so we basically successfully create the agents. Each agent is hooked up to their own tools, right? And now we'll okay, and now we'll create the task, right? So we'll try to create the task. So when you look at creation of the task, okay, I'll pause a bit here. If there are any questions in terms of the agents, I'll directly take it so that it's easy to move forward. So I think, okay, Abhinav is doing a great job answering all the questions in chat and in Q&A. So thank you, Abhinav, for that. So I think, yeah. Yeah, so there's a question on allowed delegation. So allowed delegation means that whether the agent is allowed to give the work away to some other agent, right? Whether that agent acts as an orchestrator or a planner, or whether the agent acts as a like a doer, right? Worker, right? So that is what is allowed delegation means. And you can see that all of these allowed delegations are false, right? Which means these agents have to do their own work properly. Okay. We are using a single LLM for all the 3 agents, right? We are using the OpenAI LLM itself, right? Chat OpenAI, we have only one key. Choice of an LLM doesn't really matter apart from the cost, right? Because all LLMs nowadays have similar capabilities. Unless you are doing very deep thinking, where you might need to have the very costly models, like say GPT-5 or like say 4o, the advanced models of 4o, and then you might have the Claude Opus ones and so on, right? So all those cases, in all those cases, you will have like you might want to use some different LLM for some specific task, right? For the researcher one, you might want to use say a very complex LLM, right? But other than that, we don't fret a lot about the LLM, right? For any basic things, for any POCs and so on.
Hey, Parijat, sorry, I think
Yeah.
I missed.
I think, yeah, I think my Zoom crashed. Can you hear
Oh,
me now?
yeah. We can hear you now,
Okay.
but
Okay.
we can't see your screen, what you were
Yeah,
sharing.
I'm just setting it up. Yeah, I'm so sorry for that. Yeah,
No worries. Yes.
yeah. Sorry for the disruption. So let me share my screen back. Yeah, it just momentarily crashed for I think 2 odd seconds. So I hope like all of you could hear the last bit, right? I'll repeat it once. Yati, I hope it is visible now, right?
Yes, we can see your
Okay.
screen.
Thank you.
We
Thank
can't
you.
see you though, but we can see
Oh,
your screen.
oh, is it? Oh, okay.
Now we
Okay.
can see you.
Okay, I
Perfect,
think the
perfect. Thanks.
camera blocker was there. Yeah. So just talking about the 3 agents, right? Now we will talk about how we combine them or how they talk to each other via Creo AI, right? We have not looked at Creo AI capabilities yet. So how do you set up the serial flow, the parallel flows, and so on? So that's what we'll look at, right? How the context flows, right? And there is already a question in chat around that. So how is the context flowing? How do we know that the agent has a role and a goal, right? So that's what we talk about now. Okay. So you can see here the T1, T2, and T3 are the tasks. So again, I'll zoom it in a bit. I think this is the maximum I can do to show all the three tasks, right? You can see the expected outputs, right? And you can see the context. So whenever you see context, you know that, okay, this has to be done serially, right? So T1 has to be done before T2 can be done because T2 is being passed as a context to T1, right? If T2 did not have a context, then T1 and T2 could have been done parallelly, right? But we have the researcher agent first, then we have the writer agent, and then we have the social media agent. Okay. So we have these three things, right? I'll just hold it here a bit so that you can see the expected outputs of each, right? What are the descriptions of each based on what we have already talked about, right? And how we are passing the context, right? So we are just defining the tasks. So this task, this agent, these are all Creo AI constructs, okay? So you can see here from Creo AI, we have imported agent. So these are the agents, right? From Creo AI, we are importing tasks. Those are the tasks and so on, right? So these are all Creo AI constructs. Okay. And I think there's a very interesting question that I just wanted to address in chat in terms of like what is the importance of using Creo AI instead of LangChain family tools, right? So they're not really competitors. I'll say they solve problems at different levels of abstraction, right? So LangChain will give you the components and Creo AI will give you the collaboration tools. Okay, so LangChain helps you build one agent altogether, right? So the topic, the notes, the articles, and so on, right? The invoke functions and so on. But Creo AI actually gives you the context. How do you process, whether it's sequential, whether it's parallel, and so on, right? Whether it's synchronous, whether it's asynchronous, and all these things are handled by Creo AI. Okay, so this is how the Creo AI works. So you can see here, we are now creating the Creo. We are setting up the agents, right? The researcher agent, the writer agent, the social media agent. We are giving the tasks, right? These are the tasks we want to do in this sequence, right? And finally, we look at the verbose true. Verbose true means we want to see what are the internal logs and so on, right? If you set it to false, you will just see the outputs. You will not see the detailed outputs and thinking and all these things, right? So you will just see the basic outputs, right? So LangChain and Creo AI can definitely work together in one particular AI, like in one particular task, right? You can have one agent built in LangChain and like all the agents built individually in LangChain, and then you can use Creo AI to work with the agents. Okay, so that is also done here. Um, was done somewhere, I remember. Let me see. Okay, not in this one, but yeah, I think you can definitely do that. Okay. So now when it runs, right? So I just triggered it. So when it runs, you can see that the first thing was the research, right? So you got the task completion for the research agent, right? So name was create social media. This is the whole agent, and then you see the workflow, right? The execution trace. You can see like what are the execution traces, right? So individual agents, right? What they are trying to do and so on. Okay, and yeah, I'll just show you the step-by-step running of this, right? So this is how the task started, right? Because we have put verbose equal to true, right? You can see Creo execution task started. Okay, so when Creo execution task started, right? First thing was the research the topic, right? It will go to the researcher agent first, right? It will look at the topic. It will say find five key insights. Remember, I told five bullet points the researcher will give, right? So it searches, it gives the five key bullet points like post-pandemic recovery, oil and natural resources sector, labor market challenges, technical innovation, geopolitical risks, and so on. So you have all the five things, right? The researcher agent gives you. Okay, this is the first step. This is the output of the first agent, and this has to go as the context of the next one, right? So we had built it like that. So this goes as the context of the next one. So you can see here, then the next task starts, right? So the next task starts, which is like write a structured 250 to 300 word article from the research notes, include compelling title, introduction, 3 to 4 sections, conclusion, and so on, right? So we have all these things together, and that basically helps you build up the writer, right? That goes to the writer agent. That agent starts working, right? And it gives you an answer, right? Writer agent is a essay writing agent, right? It writes a big answer with a compelling title. The title is Canada's economic outlook, navigating post-pandemic recovery, right? And then you have the summary, the individual paragraphs, right? The pros, cons, geopolitical risk, trade, and the conclusion. Okay. So this is all that is there from the second, the researcher. This is the essay writing, the second task, the second agent, right? So this was the writer agent. Okay. So the task completed. The Creo AI says that the task has now been completed, and then we go into the third one. Right. So the third one is essentially the social media strategist, right? So it will basically create a social media post from the further article, right? So when it creates the social media post, you will be able to see, say, a very, very small, very, very crisp outline of the whole thing. So Canada's economy is on the rebound, exclamation, with a predicted GDP growth of 3.4% in 2023. The path to recovery looks promising, yet challenges remain. Dive into the latest article to discover the forces at play and what lies ahead. Read more, and the link. The link is to the full article, right? The long essay, the long writer agent output, right? And for this, we are passing both one and two as inputs, right? Both output of one and two. And then you can see like it generates all the different versions. For LinkedIn, it generates a version. For Twitter, it generates a version, right? For like, so for these different types of social media, it is generating the right versions, right? And with the right hashtags and so on. Okay. Right. So one common question comes is, how is the agent being able to define these? So these are using all the OpenAI, your OpenAI key and everything, right? The LLM, underlying LLM is the OpenAI key. So it's as if you are not doing the manual things. It's as if the agents are doing it, writing the article, creating the post, and if you give it authorization, it will even post it via the webhook, right? So that is what it is doing here, right? As to the why we are using emojis, because these are social media posts, right? In social media posts, you generally have emojis. So ChatGPT or like OpenAI has figured it out, and that's where it is putting emojis here, right? You can see that the longer versions are not putting any emojis, right? These are proper essays, proper text, right? So the context, the understanding also is there, right? Here if you see, there are no emojis. It's an essay, it's a proper essay, it's a proper write up, right? Even the researcher part, you will see there are no emojis, right? But when you are trying to post it, because it's social media, there are emojis there. Okay. And the emojis are more or less like contextual, right? So you can see like a rocket kind of thing means GDP is increasing, and so on, right? So it's not like anything like random or anything smileys or something like that. Okay. So they are like OpenAI is capable of understanding the context and building the code as we have, right? So that is it in terms of the completion. And then it says that the task is completed, the workflow completed, right? And finally, you can also view insights, right? As to how much time it took, how much, were there any errors, were there any retries, how much token you spent, and so on. If you do yes here, you can see those details also, right? In more detail, right? So how much, what tools were used, what was the task IDs, and so on. Okay. So this is the demo. I think there was a question around where are we using OpenAI here. So OpenAI we are defining based on the key here on top. So let me scroll up, right? So this is the OpenAI key that we are instantiating, right? And we are using it here. So this one, GPT-4o Mini. Okay. So whenever we are calling the prompt, we are calling the prompt basically through the LLM, right? It's llm.invoke prompt.content. Okay. So this you can change based on your keys. You can change it and so on. Okay, OpenAI is not free. OpenAI has, I think, $5 minimum charge that you need to use. I showed that key provisioning steps. If you want to use something free, explore once. I think Phi Llama, they have like smaller models which have free versions. Okay, can try to look at it. Yeah, there is a feedback that in an enterprise level app, we please don't use emojis. Uh, yeah, it is not an enterprise level app. That is the point, right? It's a social media post, so that's where the emojis are used for. Yeah, if you are using like enterprise related things, or if you want to post, or if you are say writing a research paper, LLMs are capable of figuring it out that you don't need to use emojis there. Okay, because we are creating a social media post, the emojis are there, right, and so on, right? uh, LLMs are that much capable. They understand context, and so if you give context properly, it will be able to understand what type of thing you want to use, right? And you can always be. It never hurts to be explicit. So you can always tell, don't use emojis, don't use short forms, don't use hashtags, and so on. Right here, we have mentioned use hashtags, right? Because it has to go to a social media post. Okay. So yeah, I think that brings us to the end of the today's this session discussion demo. I think a lot of you were interested in the demo parts. For publishing, yes, you can use MCP servers, you can use LinkedIn, Twitter APIs, right? So it is not, you can use with your ID, with your token, with your handle, right? You should be able to post it. So yeah, that is mostly it. Okay. So Niyati, if you're there, over to you.
Yes.
Yeah.
Yes. Yeah. Okay. Thank you so much, Parijat. I think it was a wonderful session and the demo. A lot of people were waiting for the demo, and rightly so. I'm going to take over and, uh, like yesterday, I'm going to talk a little about interview kickstart and use this time. While you guys hear me, maybe you can take a break simultaneously. That would be great. What this would do is, a lot of you are not just looking for 2 day uh, you know sessions, but something that is more concrete, and something that you can carry forward in your career and can future proof your career. So I'm going to start a video by our co-founder Ryan, and a lot of you will be able to relate to it. So let's go ahead and listen to him.
AI is no longer the future. It is here, it is the now, and it is the skill that every single person in technology needs to be on top of if you want to survive and also thrive in the next many, many, many years. This AI wave has unlocked unprecedented opportunities for all of us. If you look at all the hiring over the last few quarters, you see that all the growth has really come in AI roles, and now increasingly so in AI-enabled roles. Far more importantly, the compensation that we are seeing here, going up to $1 billion in some cases, is unheralded. It's unprecedented and nothing that we've ever seen before. We ourselves at Interview Kickstart are constantly seeing our own alumni who are AI-enabled or have AI and ML skills getting offers, and in many cases are $300,000 to $400,000 more than their peers, simply because they have the AI skill set. The challenge, though, is that AI is moving at warp speed. It's moving so fast that it's very difficult to figure out both where to start and how to pick a path that is customized, or to use a word often used these days, fine-tuned for you. That's where we at Interview Kickstart come in. We have built a career acceleration platform that helps you turbocharge your career with AI skills. We've been doing this over the last 12 years, and I've already worked with over 25,000 working professionals from all domains in tech: software, product, data, ICs, managers, and the entire like. Our approach is unique. We believe that the frontier of AI has moved to the world's best companies and the world's best AI labs, which is why we bring together a platform of over 700 instructors, all of whom who come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. We bring together a platform of over 700 instructors, all of whom who come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. We bring together a platform of over 700 instructors, all of whom who come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. Everything that we bring to you is designed, developed, and delivered live by these professionals. And so they bring their frontier lived experience to every single classroom. We also believe that the world has changed. It has moved from an era of passive learning to now active building. And so in each of our programs, you will get your hands dirty. You will build AI projects, all oriented on helping you build an AI portfolio, because that is what is required today if you want to turbocharge your career. Finally, we realize that there is no one size fits all in AI, and AI really needs to meet you where you are at. And all of us are at different levels, have different experience, have different backgrounds. And so we offer a plethora of courses that is completely flexible. They range from 3 months, 6 months, 9 months, 12 months, spend more than a year as well, based on your career goal. They're fine-tuned for every domain. We have 18 to 20 domains that we cover. We have separate courses for ICs, separate courses for managers, and we have versions in pro code, low code, and no code. Bottom line, we want to meet you where you are and work with you step by step as you up level to building a fabulous AI career.
Yep. So that was Ryan, and I'm sure a lot of you relate to what he was saying, and the fact that in the poll when I launched at the beginning, 67% of you said that you want to layer your current tech stack with AI skills. So whatever is your domain, you want to stay in that and learn AI skills as per that, right? Yesterday, when I asked a follow-up question in the poll again, that what are the blockers everybody is facing? If some of you would remember this, that 33% of you said that 32% of you said you need a structured program, and 32% of you said that you don't have the AI skills to crack those top tech interviews, and followed by 32% said that you don't have a structured approach. Now, because of all of that, because of so much of upskilling in AI being such a table stakes now, you would you might be in either of these four quadrants, and that means that you may feel it's moving too fast. You don't know where to join the bandwagon, and if it's the right place to join the bandwagon, and if you have seen a number of free YouTube videos, have you even learned enough, right? Learned enough to actually deploy that at work. Second is, there's too much out there. You don't know where to start. It's so unstructured. It's so every day there's something about on LinkedIn or on YouTube that this thing launched and it broke the other things that were existing already. You don't know whether that's all for clicks, or they are actually those are true claims. The third is that you now, whereas like I was saying yesterday, not a lot of people feel that this is true, that you don't feel that your job is too unique. Tech, non-tech, across AI is actually amplifying a lot of our work and a lot of our productivity and transforming our systems. And the fourth is, which a lot of our senior learners feel. Most of our learners are like about 8+ years of work ex. We take learners who have about 3+ or 5+ years of work ex, and most of them find themselves in the senior bracket, which is 8+ to 20+ years of experience. And they have that fear that, hey, would I have to start from scratch? And would I have to down level to sort of learn these skills? All of this is untrue. All of these are just myths, which we are going to debunk today. When about 3 years back, AI started becoming part of our daily lives, our work lives, it started as an augmentation tool. Okay, it started as something that increased our productivity. It would review our things, and we would have these quick chats with it. We would have co-pilots reviewing some of our code, etc. But now it has actually taken, and it's slowly taking form and shape that is truly, truly transformational, right? And that's where people want to learn skills, where they want to build AI agents, they want to build complex AI multi-agent systems that can actually do a lot of their, that can amplify their work. The second and the third box over here is when you want to using those skills you want to sort of up level the existing ML models or make new ML models, right? And using AI, it's going to be a completely different thing altogether. Now, if you want to do either of these three things, three, four, five, and you want to become, for example, if you're a software engineer, you want to become an AI enabled software engineer, you're a product manager, you want to become an AI enabled product manager. And all of these are important. If I don't know if you guys read that study, LinkedIn recently, came up with that study that about 44 to 46% of tech job descriptions have AI skills as mandatory in them. Okay, they are not a good to have requirement. They are all must have requirements now. And companies are coming up with positions like AI engineers or AI software engineers and all. So the first point that everybody needs to start, and I understand a lot of you might not want to start, but for people who actually are interested to start and say that today is going to be that time, I'm going to start up skilling in a structured way, such that I not only learn the skills, but I also be able to crack interviews. Then I'm going to talk about two programs, okay? And so bear with me while I do that for people who want to make the most of this. Is First is, and if you don't know where to start, you start with this Transformative Gen AI and Agentic AI plus Interview Lab. This is a 6 month program, 3 plus 3, 3 months of AI up leveling and 3 months of interview preparation, where we, as per your domain, as per those 18 domains that I was talking about at the beginning, uh, we will help you up level in AI. So your projects will be customized, your track would be customized. It will be customized to a pro code, no code, low code level also. So if you, for example, you're a product manager, we will put you in the no code track. If you're a engineer who is proficient in coding, we will put you in the pro code track. The second part to this is the interview preparation for your domain, interview preparation for those AI rounds nowadays that you have, right? Where you have to reason and you have to show your AI judgment. So you not only show your AI skills, but also your AI judgment, because they will ask you things like, for example, what Parijat was talking in the beginning of the session. Is this a single agent problem? Is it a multi-agent problem? Is it a build versus a buy problem? What is it, right? All of these reasoning you would need. And apart from the skills, we will also help you figure that out. The second program, the Green Box, is a program that we give in association with our industry partner, who is PwC India. So if you are already proficient in coding, it's a pro code track. So this program is a pro code program, where if you're proficient in coding and you're already somewhat, you have started building agents, you know what's RAG, MCP, and all of that, and you want to build an actual enterprise level portfolio of projects so that you can signal that to people who are taking your interviews and be like, I've actually built enterprise level projects. Then this is a 12-week plus 3 months program, 12 week of just building projects, 3 months of preparing for interviews. You can take this up and you'll also get a PwC certification in this. Okay. Now, what are the 18 tracks that we have? We have these, 18 tracks that are in front of you. So we cover all forms of software engineering, which is backend, front end, full stack, iOS, Android, test engineers. Then we have data engineers, data scientists, ML engineers who join our courses, SRE DevOps, so all the system folks, SRE DevOps, system embedded software engineers. Then we also have management, tech-based management roles, which is engineering managers, senior folks, typically with 12 plus 15 plus years of work ex, tech product managers, technical program managers, and then we have a separate course for early engineers who are typically they have 2 to 4 years or 2 to 5 years of experience only, right? What do we do in our interview preparation and career support, those 3 months? We cover as per, and this is more generic, but as per your domain it may change. So we cover DSA concepts, we cover system design, we cover interview modules that are specific to your domain. Okay. And for example, in EMs, we also cover leadership round. Apart from that, we give you 15 mock interviews with people like Parijat or Justin, who is our next speaker. These are people who are actually hiring in these top Mang Plus companies, right? You're going to hear from the horse's mouth on whatever answers you're giving. Is it right? You get verbal written feedback. We optimize your resume because your resume is not going to be, it has to have the AI elements, what ATS and hiring managers are looking for. Okay. So you need to be able to optimize your resume. You have to optimize your LinkedIn profile so that you build certain personal branding, which can put you forth in the whole deluge of people who are trying to search for a job at this point. We also have preparation rounds for salary negotiation and behavioral rounds, and we have about 200 plus hiring partners in India, where if you successfully complete a course as per our eligibility criteria, we put forth your profile in whenever there are some openings in our hiring partner companies, and our hiring partner companies involve names like Microsoft, Google, Meta, etc. Also, our instructors go ahead and refer you folks, if there are job opportunities available. So you also get direct referrals in some cases. Now, this was the time period for each of the both of the programs. So, like I've written here, start here if you're unsure. This will layer 67% of you said this. So, for 67% of you, this program is absolutely applicable. And I'm sure for the rest of them also, it's applicable to 33%. Uh, and it will make you an AI enabled tech professional in your own domain. Okay. And if you're already proficient in coding and some AI knowledge, then go ahead and get an industry certification and build a portfolio straight up, right? So 12 weeks of that, 3 months of interview preparation, 3 months here also, and 3 months of AI skill. So within 6 months, you are completely ready and confident to crack that, not just the next role, but also future roles. Now, this is the costing for both of the programs. The costing for transformative Gen AI and Agentic AI plus Interview Lab program is 1.5 to 2.8 lakhs. It is dependent on your domain. So you can get in touch with your program advisor and figure out what is the price for your domain. Similarly, the PwC India Agentic AI Accelerator and Interview Lab also has differential pricing of 2 to 2.8 lakhs. We have a 50% refund policy in some cases, and you can figure that the details out with the program advisor. We all of our learners, of course, come from, like I said, they're senior folks, they already have families, responsibilities, etc. So we have EMI partners that can break it down to smaller installments, which will help you not you can get the benefit of upskilling without feeling the load of the money that you have to give. We also have some scholarships running at different points of time. You can check out what is the recent scholarship policy or scholarship offer that is going on with your program advisor. They're going to get in touch with you after this session from tomorrow onwards or today if you go ahead and book a call with us in the calendar link that I shared. Okay, so I'm going to launch a poll in some time, and you can let me know that if, and I'm going to just go ahead and launch the poll right now. Let me know if you want our program advisors to get in touch with you and either help you enroll in the program straight away, or if you want more information about the programs, get a personalized consultation on how is it applicable to you, etc. You should definitely go ahead and book a call. I'm going to share the book a call link also. So now I'm going to hand it over to our next speaker for the day, and this is our last session for the 2 days of Launchpad that we had. And we are going to be covering the production aspect of these multi-agent systems, right? So we are going to see from demo to actual deployment in production. You're going to get the recording anyway. This is a live session, so you won't be able to follow along at this point, but you can always check out the recording at a later stage and at your own pace, and you can go ahead and do it yourself too. These are the free resources that I already mentioned who is it for. I'm going to jump into introducing Justin, who's the speaker for this session. Justin joins us from Ireland, and he's a staff AI engineer at Analog Devices. He is actually a homegrown boy. He studied in BITS Pilani, and I think it's about 10, 11 months back he shifted to Ireland for a job that he got over there. It's been 10 years or over 10 years. It's written 9 years, but it's almost been 10 years for him in various AI roles. And he's done a number of these sessions for us. So I'm definitely sure he's going to have a good one even today. So over to you, Justin. Welcome, and please go ahead and share your screen.
It's Niyati, by the way. Hi, everybody. Give me a moment. Let me just screen, and I hope you can see my screen. Uh,
Yes.
yeah. Hi, everybody. Good afternoon. Hope you are having a great day. So, I'm Justin Joseph, and I'll be your instructor for the next 1 to 2 hours. So, I'll be covering LLM ops. I know LLM ops is a very detailed topic, but I'll be covering it in a superficial way with some of the concepts that we have with an example that we have curated, and I'll be sharing the code as well as the instructions on how to run it in a detailed way. Don't worry about that. So you won't be able to follow me in this complete deployment part, but you will be able to, what do you say? You will be able to replicate it later on. So a quick introduction about me before getting started. My name is Justin Joseph, and I work as a staff AI engineer at Analog Devices, and I am based out of Limerick, Ireland. And I work for their European Research and Development Center, and I specialize in industrial automation, in um, developing AI products, facilitating industrial automation. And recently, I've been working on physical AI systems. That means bridging the gap between robotic systems and the AI systems. So that is what I predominantly work on these days. So you have seen the multi-agent systems. You might have seen the um, Cloud Code, ChatGPT, all of these that interact on a software front. But from a hardware perspective, things are still years behind. So we have a lot more progress to be made from a hardware perspective, so that you have autonomous robots, so that you have something humanoid hands that automate manual jobs, etc. So that is what we're working towards, and I have around 10 years of experience in this field. So I started as a uh, AI consultant, and then moved into an AI engineer role, then a senior AI engineer role, then currently I'm a staff engineer. So that's about me, and I do build multi-agent systems, RAG systems, computer vision models, natural language processing models, etc. Um, as a part of my job. So that's about me. Let's get started with today's session. And before working with analog devices, I was working in Bangalore for Siemens, and it's been 1 year since, more than 1 year since I've been here right now. All right. So you had foundations on day one, and you had some builds complete in day two. Today we'll focus on LLM ops. The idea of LLM ops is taking an LLM and productionizing it, something as simple as that, but something not so simple as that. So we'll go through the components involved. I'll try to give you a very high level picture of what's happening, and then um, we will go into understanding how this is to be run. So let me start with sharing the GitHub repo. By the way, one of the learners have mentioned, one of you have mentioned that the sound is not clear. Am I audible, or is there an issue with the sound? All good?
All good.
Okay, perfect. Okay. So here is the GitHub repo. You would require it. And I've also, um, so in the GitHub repo, so the idea is actually very simple. In Hugging Face, which is Hugging Face is, wait. So Hugging Face is a repository of models, databases, etc. that we have. And in Hugging Face, we have a model called Microsoft Dialog GPT Medium. And this is a simple LLM where you can provide a conversation and it will respond to you back. So we are taking this LLM and we are productionizing. That is the objective for today's session. Now, In order to do this, we'll use multiple components. We'll be productionizing it in AWS, by the way. So I'll be going through all of the components involved. I'll be going through how the components work together and all of this. Now, I've also curated a document that can possibly help you in deploying this end to end. One moment. Yeah. So you can utilize this along with the GitHub. So in the GitHub repo, you can just clone the GitHub repo and then you can run these steps if you want to deploy it to your own, um, what do you say, your own AWS instance. So the complete list of steps, starting from creating the clusters, creating the nodes, to building the BentoML, to containerizing your application and then deploying it, all of it is mentioned here. All right. Now, okay. And if you want to deploy it locally, you can just follow the steps that we have mentioned here. See, just clone it, cd into the particular folder, and then install the requirements to your system. And then when you run the BentoML serve, this will spin up locally. And then you can test this using the curl commands. And you can also run a front end using this. And then you can just visit the local host and it'll be populated in your local host. We can see it, don't worry. All right. So first, I just give you a very superficial idea as to what we are going today. But what we are going to do today, as to how we are going to do today, we didn't talk about it yet. So I'll I can show you the what do you say, local deployment, but the production deployment takes time. For instance, creating the EKS clusters, it takes around 20-25 minutes. So you will have to wait until that completes without doing anything. So which is why I spun everything up earlier for you so that everything is in place and everything is running. And I just checked whether it is running and it is actually running in place. And we'll be discussing the component and then you will get a better picture of what's happening. And then we can also look at the dashboards as to how the current progress is looking like, or as to how the current application is running, all of this. Now, let's get to the slides. So MLOps adjusted for handling large language models is what we call as LLM ops. And when we talk about LLM ops, it is about deploying LLMs to production and managing the model lifecycle at scale, ensuring that it is reliable and ensuring the performance is up to date and ensuring that there is sufficient monitoring so that you can keep a track of the costs, you can keep a track of the number of tokens, etc. Now, okay, all right. Okay, so so here we have the machine learning notebook on the left. And this machine learning notebook and the production system is on the right. That simply means that we are taking whatever code that we have and we are pushing it into production in wherever we want. So you can productionize locally, you can productionize it in AWS, you can productionize it in Azure, wherever you want, or even in your private VM, wherever you want. Now, this is what we exactly do in a production system. Now, there are a lot of components involved in between, and that is what we will be discussing as the session progresses. Now, when you research and develop something, you'll be working predominantly on Jupyter notebooks, and it'll be just you accessing the system. That means you can just probably anticipate one or two requests, or probably 5 or 10 at most in concurrence. Now, the problem is when you scale it, when you have thousands of users, and that is where the problem comes into the picture. When it has to be scalable. Now, you have thousands of concurrent users. You require a 24/7 availability, and you require cost optimization as well here. Now, all of this are what makes it tricky. And also one more thing, the okay. And yes. And you need also automated monitoring. That means it needs to keep a track of how your deployed software is working, how many users is it handling, how many requests is it receiving in real time, and is it able to cater to all of them, is it crashing elsewhere. All of these information that you need should be provided to you as graphs or in a pictorial way. So you need proper monitoring as well, and also automated alerts. We are not going into all of these at this point. Now, what we will do today, or what we'll take a look at today, is we are building a production grade LLM API with an automated deployment pipeline, with an auto scaling infrastructure, and a complete observability stack. Now, the tech stack we have is Bentoiman, Docker, Kubernetes. Kubernetes is not mentioned here. AWS, GitHub Actions, which we will use for this. So, sorry, we have 5 tools and 5 jobs. And at the end of the hour or at the end of the 2 hours, you will understand exactly what is the job that each of them does. And you will also see how they work together in one single cluster. It's not a slide that you will be seeing. You will be seeing an EKS cluster with actual jobs. Now, uh, it's an open source one, so I've shared you the link along with a document on how to production deploy it without facing any issues, because I just deployed it yesterday night and it was working fine. And I'll also show you the graphs that you can see. Hold on a moment. Now, but before going into all of this, I need to explain what are each of these, right? What exactly are these? How do they work with each other? You need a bigger picture of this. So, which is why we have the next slides. Starting with what is a Docker? So, some of you might be aware of what a Docker is. So, the idea is, see, without using Docker, if you decide to run an application or build an application and you're testing it and you send a copy to me, I try to run the same application. And you might have Python version 3.9, I might have Python version 3.10. And you have the requirements file which has the Python packages. You install the Python packages with it. But your system might have some additional Python packages as well. And my system will only have the files or the packages installed using the requirements file. Now, there are differences between my system and your system. It could be yours is Linux, mine is Windows, yours is probably an AMD architecture, um, mine is an Intel architecture. Sorry, yours is AMD, mine is ARM, etc. So all of this could cause further mismatches. And then the classic problem would arise. It works in my system, but it doesn't work in your system. And Docker's objective is to primarily mitigate this. So Docker creates a standalone executable package, which is called a Docker image. And this Docker image contains your application. Now, the idea of Docker image is that Docker image packages your entire code along with the required dependencies for it so that it'll be a Docker image. And this Docker image, once you spin it up in your system, it'll be a Docker container. And the Docker container has all the prerequisites in order to run this application standalone so that it'll work in any system. You won't have the issue that it works in mine, but it doesn't work in yours. So, which is why, for deployment purposes, we containerize them and then we take it to the to wherever we want to deploy it, and we go ahead and deploy it because we have the complete application plus all the dependencies in one single unit, which is our Docker. So next time somebody asks you what Docker is, just remember it fixes the classic issue of it works in my system but doesn't work in your system. Now, the container, what we have, the Docker container that I talked about, the container shares the operating system kernel of the system that it is working in. So the container is lightweight. The other alternative that you can have is a virtual machine. The problem with a virtual machine is you require a complete machine in order to run this. And the difference between container and the virtual machine is that the container is lightweight and fast, while the virtual machine is heavy and slow. Now, the image, the Docker image, is the blueprint that we have, or the recipe that we have on how to spin up the container. And once you run the instance of the Docker, that is the meaning of container. So you have a running instance, and that is a container, a Docker container. Now, a Docker file is like a TXT file, it's like a README file, it's like an MD file that consists of the set of instructions for building the image. So Instructions on how to build the image is a Docker file. The image is the actual blueprint using which you spin up containers in your system. No, I told you what issue Docker fixes. And we are using Dockerization here in our application before deploying it. Now, another component that we have here is the Kubernetes. So when we talk about Kubernetes, the thing about Kubernetes is that, see, we talked about containers already. Now, Docker solves the issue of how can I package one container, but Kubernetes solves the issue of how do I manage hundreds of containers without manually having to track them or without manually having to handle them. That is what Kubernetes does. So Kubernetes is a container orchestration. So Kubernetes, it's a container orchestrator. Orchestrator. Now, Kubernetes ensures that all the containers keep on running. Kubernetes ensures that it scales up if the traffic increases. And also Kubernetes ensures that it routes the network requests to the appropriate containers. So Kubernetes is like a container orchestrator. Now, within Kubernetes, you have some building blocks. One is the pod. So a pod is one or more containers running together. Then there is deployment. A deployment declares a decide state. That means something like I want to run 5 pods. So that decide state is declared by the deployment. And then the Kubernetes ensures that whatever the deployment requires is taken care of and it keeps the deployment true. And then you have a service. A service gives you a stable network access to a set of pods, even though individual pods might come and individual pods might go. So the services requirement is to maintain a stable network to the pod. Now, there is the horizontal pod autoscaling and vertical pod autoscaling rules. That means when the request or the demand spikes, you need to adjust the capability of the pods. So this is what Kubernetes takes care of. So Docker is, consider this analogy. So Docker is like the shipping container that you have, and Kubernetes is like the entire shipping pods, which consists of your cranes, your schedules, routing, all of it, managing these containers. So Kubernetes and then Docker. The next thing is CI/CD. CI/CD is continuous integration and continuous deployment. Some of you might have heard about it, and this is very important in case of production systems. Now, if you make change to a production code, then if you have to manually um, validate whether your code is proper and whether you want to manually check whether everything is proper and then you deploy it, there could be problems. You might have missed something, and this would be very detrimental when it comes to production. And CI/CD helps with automated software delivery. So CI is the continuous integration and CD is the continuous deployment. So what CI does is CI builds and tests the code on every commit. You make a change to the code, it automatically undergoes certain test cases. That is under the CI. So you can catch the bugs before you push it, before you productionize it. You can ensure that your production works properly and you're not here for surprises. Now, that is the CI part. Then the CD part. The CD part is where it automatically deploys the tested code that has passed the test. So no extra steps, no manual test. So here, once again, CD means every commit that you make, it makes the code undergo the tests. And then after that, it also creates your Docker out of it. And then using the Docker, you go ahead and perform the continuous deployment part as well. So your code push followed by automated tests, followed by building the image. That is what the Docker creation that I was talking about, then the deployment part. Now, this is handled. The CI/CD is handled in our use case using something called GitHub Actions. I'll show you what GitHub Actions is, by the way. So this is what GitHub Actions. Now, when you take a look at in this repo, there is the GitHub workflows folder. You go there and you can see a YML file. And this YML file consists of the set of steps or the set of jobs that once a code change is made, it has to go through. So only when it goes through all of these jobs one after the other, would it say that, okay, continuous integration has, the CI tests have passed. So I've not added a lot of tests, but you can add whatever tests that you want there as well as a part of continuous integration. Now, the next one, we talked about Kubernetes, Docker, we talked about CI/CD. Now, EKS. So EKS has managed Kubernetes. See, I'll try to keep it as simple as possible. See, EKS is Amazon's Elastic Kubernetes service. So this is a managed Kubernetes service, and it is a command line tool that automates the creation of the infrastructure. So within EKS, you have the cluster. So the cluster within EKS is known as the control plane. So the brain managing the system. That is the cluster within EKS. And then EKS has node groups. And these node groups provisions the actual physical servers and the virtual servers that you need. And in our case, we have a certain server that we are deploying it in, which is the AWS M5 X large here. You can see that in EKS, we are creating a node group with the cluster name as LLM inference cluster, and we are choosing the type of node M5X large. So there are different kinds of nodes that you can use. M5X large is sufficiently expensive, but if you're on the Amazon AWS free tier, you might want to go through some T3 micro or something like that instead of M5X large, because in the free tier subscription of AWS, they won't let you use expensive node types like the M5X large. So you can use T3 small or T3 medium or something like that that you have access to. Now, just a quick heads up for everybody who signs up to AWS, you get for the first time you get $100 free credit by AWS, so you can utilize it for deployment purposes. Now, I did tell you that EKS is the managed Kubernetes service, and EKS is responsible for spinning up the infrastructure and everything. So let's get back to our slides. Okay. So the brain has to how to make the systems highly available, how to keep the system scaled and everything. So the EKS is responsible, or the EKS cluster is responsible for taking care of that. So AWS handles the control plane, security patches, the high availability, the scaling of the underlying infrastructure. Now, we manage the application and the worker nodes. And these are just EC2 instances doing actual compute for us. Now, if you run Kubernetes yourself, you will be responsible for handling all of this logic as to how to route this, how to spin up the correct instances, how to take care of everything about the server part, how to take care of the scalability aspects and everything. Now, you don't have to do it by yourself, which is why you have the EKS to take care of that for you. So that is EKS. EKS manages the Kubernetes. So with that, going to the next one. So Kubernetes, just like Python has pip, Kubernetes has a package manager. And that package manager for Kubernetes is Helm. Now, Helm is is the package manager for Kubernetes. Now, instead of writing dozens of complex YAML files for Kubernetes, so Kubernetes requires a lot of YAML files, and YAML files are the configuration files. So in order to, instead of writing a lot of complex YAML files, you just need to use Helm, and Helm will install a pre-configured configured template for you. And this pre-configured template can ease our lives significantly because you don't need to write complex YAML files by yourself. Now, the problem with the Kubernetes configuration, having a lot of YAML files, which consists of the deployment services, autoscalers, etc., that issue is mitigated by Helm by using something called a Helm chart. So Helm consolidates all of these YAML files into the Helm chart. And once again, the Helm is also automated, so we don't need to worry much about it. So the Helm charts give you templates so that we are not copy pasting the YAML files by hand, but rather it's a one command install, upgrade, and rollback that you'll be doing. So just like your Python pip is the Python package manager, similarly you have Helm as the Kubernetes package manager. So it's the same idea as that of pip in Python, just that it is applied to Kubernetes so that it can mitigate the issue with the uh, backload of YAML files associated with the Kubernetes. Now, we talked about the Helm, we talked about EKS, we talked about Kubernetes, we talked about the Docker containers as well. Perfect. Now, after the deployment part, you need to ensure that the LLM is working as expected. You need to ensure that it is able to respond to all of the queries. You need to ensure that it is providing adequate lead time, all of this, downtime, all of this. In order to monitor your system, we use Prometheus and Grafana. So Prometheus collects the metrics that we define. So for instance, I'm just taking an example, scrape the metrics every 15 minutes by default, for instance. And then you can store them as time series data. And then Grafana's responsibility is to take the data that Prometheus has acquired and convert them into meaningful dashboards or meaningful alerts. So life is easier for us. You can visualize it properly. Now, the flow is like this. The app exposes our metrics endpoint. Like for example, health is an endpoint that we are exposing. Prometheus scrapes that endpoint and Grafana renders that into a graph so that it can be used for visualization purposes. Now, we talked about a lot of components involved here. Let's put all of them together so that you can get a bigger picture. And you start with the data. Your data might consist of proprietary data, public data, etc. Now, your data will flow through these data processing pipelines into embeddings and vector stores. So the data that you have is used to create embeddings or vector stores. Embeddings or vector stores are numerical representation of your data. So your data might be textual. You might need to convert it into numbers. So the embedding generation methods are what helps us to do that. Now, this embeddings or these data is used to feed to a pre-trained LLM. And that LLM can undergo fine tuning if required. And once the LLM has undergone fine tuning is totally optional. Okay, you can use an off-the-shelf LLM and you can do it, no issues. So fine tuning is generally for domain adaptation purposes. Now, that's not the point. The point is that we have a pre-trained LLM or a fine-tuned LLM, either of these, and this LLM is exposed through an LLM API, and then it reaches the mobile and other web applications that you can utilize with it. Now, the entire thing that is titled LLM ops here, which involves model versioning. One moment, some issue with my part, I think. Okay, which involves model versioning, caching the model, monitoring the model to ensure that it is working as expected. So all of this, and also, if you want, there is the reinforcement learning from human feedback. So at the end of the process, it is given back to the user, and the user validates the response and gives it back to you, and then you can update the model by using reinforcement learning with human feedback. So all of this comes under LLM ops. It's not just one tool; it's a discipline which keeps all of the production systems alive, which keeps all of the production systems available, current, and observable at the same time. So this is what the component or the system looks like. So just to give you a quick overview, so we didn't discuss BentoML, right? We will discuss that soon. So we talked about Docker, we talked about Kubernetes, we talked about ECR. Now, sorry, we talked about EKS. Now, we also talked about Helm and its requirement. We also talked about Prometheus and Grafana. Perfect. Now, for this demo, for this demo, we are using some specific tools. And one of the tools that we use is BentoML. And the purpose of BentoML is, see, before going here, the previous steps, whatever we discussed, EKS, clusters, or um, um, clusters, the Prometheus Grafana for monitoring, all of this that we discussed earlier. So all of this were general. That means they are used in almost all ML systems or deployment systems. Now, we will take a look at some other tools, starting with BentoML. See, uh, instead of something like Fast API, you might know what Fast API is. So you need to have, once you create a model, you expose the endpoint of the model using something like Flask, Fast API, Django, etc. So instead of that, we are using BentoML here. And there are multiple reasons as to why we prefer BentoML to do this. Is first thing is because it has inbuilt model versioning and it has automated API generation. So we don't need to write the rules by ourselves. Sorry, we don't need to write the routes from which endpoint to which endpoint it goes. We don't have to write the routes ourselves. So that is also taken care of. Now, um, also it is capable of optimizing the data for production based on batching, caching, etc. So, all right. So if you take multiple data points and if you um, feed them in one go to the model, then that is known as matching. So I just wanted to let you know. Now, whatever we are using, the other one is Fast API, I think. One moment. Okay, no worries, not Fast API. So, with respect to the BentoML, what we were discussing is that the BentoML has multiple components which we can possibly use. Now, starting with the BentoML service structure. So this is what it looks like in code. And this is the actual pattern that in our demo, we have used in the repository within the service.py file. So in our repository, if you go, which I've already shared with you, then go to, wait, it wasn't source, I think. Yeah, this was it. For a moment, I didn't see it before. So in the service.py in source. So here, um, the real service in this repo is called the LLM inference. And here we have the different endpoints like generate. Wait, which is that endpoint? Here, generate. So this generate endpoint is to receive the input and also to give the output back. And then you have other endpoints like, for instance, health. Health was another endpoint just to check if the health of the entire system is working as expected. So just wanted to show you how the endpoints can be exposed, and the endpoints can be exposed even if you do not use machine learning models. You can just expose any software's endpoint as well using Fast API, Flask, Django, whatever that you're comfortable with. All right. Now, we were talking about the BentoML service, right? The code here. So when you look at the code here, the BentoML service has the resources mentioned here. So here it is asking for 2 CPUs and a 4 GB memory. Now, there is a init class. So this init class is the constructor of the LLM interface, sorry, the LLM interface class. So I'm not going into the details confusing you, but just know that the init class is triggered by default when you create an object for the LLM inference class. Now, the init class loads the model that is responsible to do it. Now, um, wait, okay. Now, the BentoML API that we have here, which is the generate endpoint that we have here. Now, this one, this method does the actual inference like I told you earlier. Now, if you did not have this, the problem is you would have several lines of Kubernetes YAML, and BentoML is going to give you, also BentoML is capable of giving the health check as well, I showed you earlier. So it is not just generate, it also has the health check. Now, yeah. So this is the service.py. Similarly, in the code base, you also have the bento.ml file. So there is a bento.ml.yaml. Yes, bento file.yaml. And the bento file.yaml says that this is the service that it works with. And yeah, it includes the source, the K8s folder, and also the requirements.txt. And in order to set up the Python, the requirements file is the requirements.txt. And the owner is Elias Haron. I'm not the owner of this. I just forked that repo, and the forked repo is what you see in my repo. All right. So, and also I created an additional README file which you can use. Now let's get back to business. So we were talking about the different components, right? And we are not done with it, to be honest. We also have Git for machine learning. So the Git, as usual, is for code versioning. It is to set up the configuration. It is to set up the environment product reproducibility because you have the requirements.txt file, etc. Now, the Git is also responsible for taking the feature and moving it to a staging phase and then pushing it to production. So when you talk about Git here, we will be first thing that came to my mind is that we won't be using the Jupyter notebook files. So the earlier the files were IPyNB, and they were Jupyter notebook files. So for production settings, we usually prefer the .py files. So don't worry, even if you're working on .ipynb or Jupyter notebook, it's fine. You can just copy it into the py files and you'll be good to go. Now, we talked about the unavailability of IPyNB file, and now the model serving logic that we have, and that lives inside the notebook. Now, you can read into service.py if you're interested in knowing more about that. So the Git will be used for code versioning. And another good thing about Git is the Git also has provision for GitHub Actions, and which is using which we have done the CI/CD part. All right. Now I told you the bento.ml handles the containerization part. So you start with bento.ml build, then you go for bento.ml containerize, and then you go for bento.ml. Then you go for the Docker push. So what happens here is, see, the first thing is to package the service. The second thing is to create the Docker, and the third thing is to deploy it. All right. Now, the full details as to how to containerize it and everything is in the um, in our uh, in our code. So one moment. So if you remember, I was asking you to containerize bento ml containerize. See, this is where the containerization is taking place. So you can just follow the list of steps mentioned in this document in order to perform the deployment by yourself, because like I told you, it's a time consuming process. Sometimes you might have to wait for 20-30 minutes for an instance to spin up properly. So just giving you a heads up, that's all. All right. Now let's continue. So the bento ML produces the image, the standard Docker tagging, and it also pushes this into Amazon ECR. And this is the container registry that the AWS provides. So we already had a discussion about the EKS. ECR is different. ECR is the container registry by AWS. So whatever containers that you create, it will be with EKS. Now, the question that might be there in your mind is about Kubernetes. So you might be thinking, why do we use Kubernetes specifically for LLMs? And why don't we just run more copies inside the container? Why do we even have Kubernetes in the first place? The advantage here is auto scaling. So when we talk about auto scaling, it can auto scale the pods from 2 pods to 10 pods automatically as the load changes. And um, see, it also depends on, it also provides the capability for a pod to self heal when it crashes. And also, it provides a load balancing capability as well. So, it also provides zero downtime requirements, and it also provides proper real time resource management as well. So, this makes it quite convenient for production purposes. Now, on the image that we have the horizontal pod autoscaler as well as the vertical pod autoscaler. So, the horizontal pod autoscaler will add an identical pod or a copy of an identical pod when it is required. The vertical pod autoscaler, it gives an existing pod more capability or more resources than adding new pods. So vertical tries to retain the number of pods and providing adequate support. And now horizontal is simply about creating additional prompts uh, as per requirement. Now, so in this case of the repo, we created the EKS cluster using um, one moment. Give me a moment. In this repo, we created the EKS cluster using, yeah, this one. EKS create the node, this one here. EKS create the cluster, and the name of the cluster is the LLM inference cluster. And I did mention the requirement of EKS as well, right? So, in a nutshell, the purpose of EKS is the Amazon Elastic Kubernetes service that we have here. And wait, this is the managed Kubernetes that we have. So we already mentioned about the Amazon ECR. ECR is the Elastic Container Registry, and that is the secure system where you have the Docker images. So ECR is like the GitHub for the Docker images that you have. GitHub for the code is the GitHub, and the GitHub for the Docker images is the ECR that you have. Now, um, our objective is we will create the bento image and we will tag our local bento image and we'll push it to ECR so that the cloud servers will be able to download it and then we can deploy it using the cloud infrastructure that we have. This is the process that we'll be doing in the production part. Now, another thing is the GitHub Actions. So I already mentioned to you about what GitHub Actions are, what it does. So test, build, push, and deploy in an automated way. At the moment there is a code change in the repo, that code change triggers the GitHub Actions. And if that code change passes all the test cases, then it can be a part of the production code. Otherwise, it'll be rejected back. And then we also talked about Helm, which is the Kubernetes package manager. So here, uh, yeah, in the case of the Kubernetes package manager, so mm, our our LLM inference service is like this. And Helm creates the charts. So like, for example, the deployment YAML takes care of the pod configuration. The service YAML takes care of the networking. The HPA YAML takes care of the horizontal pod autoscaling rules. And the value.yaml takes care of the environment specific configurations. Now, when the entire thing deploys, um, when you do the Helm, see, one moment. So when you do this one, this is where you start the deployment part when you do the Helm upgrade. So that is where the deployment starts. But the start of the deployment is not sufficient. We need to have an observability mechanism. And in order to have an observability mechanism, we use Prometheus and Grafana. So there is a front end as well for this, not a front end, the charts as well for this. So you can see the charts here. There are a lot more charts that you can use. You can create your custom charts. It's totally up to you how you want to visualize the working of this. Now, when I try to run something, the load on this increases. You will see a clear change in the load when something is being run, where the application has to work on something and then return something as the output. All right. Now, from an observability perspective, I already mentioned that we are using Prometheus and Grafana. Prometheus creates the time series data. Grafana populates it in a nice way. So Prometheus is what does the heavy lifting. Grafana is more like taking the output that the Prometheus created and populating it into nice sheets and showing it to the outside world. So just letting you know what observability is as well. Now, from the perspective of a live demo, I did follow all of these instructions, these same steps. And you once you do the same steps, you can just log into this URL and you can give the username and the password, and you will be able to see the graphs like this. Now, let me just one moment. Mm, I'm just trying to stop the share and share the entire screen. All right. So you can see here that this is my terminal, and you can see in the terminal that yes, it is at 3000. So this is for Prometheus and Grafana, it's at 3000. And when you visit the localhost 3000, you can see the metrics. Sorry, you can see the metrics as well as the dashboard, everything in real time. Now, oh, wait. And see, our application is running at localhost 8080. So you go to localhost 8080. Yeah, wait. Hmm, one moment. The localhost 8080 is where your application is running. Now, if you want to trigger the application by using any input prompt. So I did tell you that the dialog GPT is simply you pass in a text and it gives text as an output. And if you want to just run that, you can just give this and you can change the input to dialog GPT. And I don't know how it works. I'm not responsible for the LLM. It's an open source LLM that we picked from Hugging Face and we are deploying it. And I am just asking, who are you? Let's see what it is. So Dialog GPT is predominantly trained to respond in a sarcastic way. And it obviously returned the response, I am a guy who can't spell. So many times Dialog GPT is not used for accurate responses, but it's rather a sarcastic conversational assistant that you can converse with it. So sometimes when you ask something like what is deep learning, it simply says that you create AI with it. No, not much information, but uh, short conversational sarcastic responses will be what you receive from dialog gpt. So here what's happening here is, see, we are triggering the generate endpoint of our deployed application. The generate endpoint is responsible for taking the input and providing the output. Now um, so you will have to reach that using postman or using the curl method or something like that in order to see how it works. And um, we gave the input in this particular format, and the input was the prompt along with the maximum length, and it gave us the response. So based on the prompt, it gave a response, and then it says the model that it used to generate the response is the dialog gpt medium, and the status is successful because it was able to generate the response. So this is a productionized system that you're currently looking at. And in order to do the complete productionization, combining all of the different components that I told, I know I named a lot of components. I don't want you to be confused, but in an actual production system, you have a lot of components. So each component has its own responsibility, its own requirement, and using which we deployed this. And you can follow these same steps. Actually, you need to follow the steps from here. The previous one was just troubleshooting. So if you follow the steps from here, you will be able to set it up properly. Probably the only thing that you need to wait for is AWS resource creation time. Otherwise, it is very quick. Now, let's get back to our business. So in our demo, I want to show you a few things. One is the local development. We can see it right away. But before the local development, the Kubernetes deployment, the Kubernetes deployment, we have already done it. And I gave you the set of steps to do it. So for those who joined a bit later, let me just share the two things. One is the code repo One moment. And another is the detailed list of steps as to how you should productionize it. So I've done it earlier primarily because it takes at least 20-30 minutes to spin up the instances and everything, which is why I went ahead and did it. So I could curate this and I could share with you. Now, the next part after the Kubernetes deployment that we should be covering today is local development. But even before that, we can do the local development purely on our own. But before that, I want to show you a few things. This is something that we will do on our own. Another thing that I wanted to show is the code changes. So whenever you make a code change, it automatically triggers the CI/CD pipeline. I did mention that. And if it doesn't pass the test case, the code change will not be reflected. If it passes the test cases, the code, um, the update will be reflected. Now, you go to the project. And if you have triggered the GitHub actions, this is how it looks like. So within the GitHub actions, it is going to show all the workflows. Starting from the workflows which did not clear for some reason, it was facing issues after issues after issues, and then I slowly and steadily mitigated them. And then you have the deployment here, which is the trigger CI redeploy and the restart infra. So we were able to rerun the CI/CD pipeline with no issues at all here. And now, yep. So just wanted to show that CI/CD part. So if you're interested, you can just go into the GitHub Actions. You can read more about what's happening there. So, um, okay. So this deploy eks.yaml is through where the complete, um, uh, what do you say, deployment workflow is written. So tests are written. So when you do a code change, it automatically triggers a CI/CD pipeline, like I told you. And in the CI/CD pipeline, it undergoes each of the jobs that it is mentioned here. And if it throws an issue in between or an error in between, then it'll be stopped, and then it won't be productionized until it's fixed. Now, we were talking with our graphs. So Kubernetes deployment is done, and the load testing and auto scaling is automatically done by the clusters that we have created. So we don't need to worry about that. And the monitoring in Grafana, Prometheus, etc. You can see it here. There are a lot more graphs that you can possibly create, and I think this spike here was because I I just sent inputs to it, quite 2-3 inputs to it right away. So which is why the spike is observable here. All right. Now, we talked about all of these aspects except the local deployment part, right? So we will look at the local deployment part, don't worry. So in our example, we have pre-built all of this. The EKS cluster, the Bento ML service, the GitHub actions, the Helm charts, everything is predefined. Now, what I will do is I'll take a bit of a time to explain the walkthrough of what these lines of code mean. What do they do? How do they combine the different components that I talked to you earlier? How do they string all of them together in order to make some sense out of it? We'll discuss that. Okay. And then we will look at the live demo just for the local deployment part, not for the production deployment, because I've already deployed it in production, so I won't be doing it again at this point. No. Okay. Now let's look at this part. One moment. Now, starting with the first part. Here, this I already have a Python installed in my system. So which is why I'm starting with that Python. So you can use any Python which is about greater than or equal to Python 3.9, and it's going to work fine. So mine is Python 3.9. So when you go to the terminal and when you just check for Python 3, you can see it's Python 3.9.21. That is what we use for the production purpose. So using that Python, I am asking it to create a virtual environment, which is called VM underscore deployment. So I can show you that. Give me a moment. The virtual environment is nothing but, wait, did I create that environment? One moment. Oh, I think this hidden files are not shown here. That's why. One moment. I can just verify that. ls-la. Yeah. Yeah. See, this is a hidden file, which is why it has a dot in front. So you can see the vn underscore deployment created here, and we can activate that file after we do this. After we create the environment, and why we create the environment is primarily because, see, if something messes up, you don't want to screw up your default Python inside your system. So which is why we create an environment. So if you have 10 different projects, it makes more sense to create 10 different environments, because each of the 10 projects will have a different dependency set of requirements from a package perspective. The version of the packages might be different, the other packages might be supplementary, etc. So you can create different environments so that in each environment you can run your corresponding project. Now, this is the first part, the VM deployment folder that you created. And after that, you're activating that environment. Oh, wait. This is how you activate it. You give the folder the correct folder name /bin/activate, and you can activate it. So one moment, I'll show it to you here. And let that be there. Okay. Now I'm saying that I want to activate this VM underscore deployment here. So you can see here that currently I'm inside the base. That means I'm not inside any environment here. Now, the moment I give this, moment I activate this, you can see that from now on, it says that I'm inside the environment, and whatever I'll run with Python or associated with Python, it is going to affect the Python inside this environment, not the root Python in my system, not the default Python in my system. So I can do whatever I want. I can screw up the Python royally, and my default Python will not be even affected, because I'm going to use the default Python here is the Python inside the environment. Now, the next step that we have is we are installing the requirements.txt, and the requirements.txt is available in here. And this consists of the set of packages that we need for this deployment part. Now, the rest of the part. So we have our Python ready with the required packages and everything. And the next part is the infrastructure provisioning. So we go to the EKS part. So in the slide, the EKS create cluster with the name LLM inference cluster in the region US East 1 without the node group. It simply means that we are asking AWS to create the Kubernetes control plane, which is the master brain inside the cluster that I told you earlier. And we are asking to create this control plane in North Virginia, which is the US East 1. Now, we are asking it not to create node groups. That means just build the brain for now. Do not build any server. Do not build any workers for now. And the next line here, we are building the workers. So we are creating the physical or the virtual servers, not the physical servers. We are creating the virtual servers, and we are attaching it to the brain. Now, the brain was created here, and the workers or the node group was created here. And we are using an M5X large node group and two of such nodes. So it provisions two M5X large AWS EC2 instances. Now, it configures an auto scaling group that automatically that allows AWS to automatically add up to 10 instances if your model gets hit with heavy traffic. So the configuration is in such a way that you can have up to 10 instances in case the traffic spikes, and the minimum is 2 instances. So AWS charges you based on your usage. So if you continuously get excessive usage and it has to max out the number of nodes to 10, your bill, the amount that you have to pay will also increase. So that's there. Just giving you a heads up. Now, once we have created the AWS EKS for infrastructure provisioning, we can go for model packaging part, starting with the BentoML build. So BentoML build, what it does is it reads your requirements.txt file. Sorry, my bad, not requirements. You have the BentoML file. Yes, the BentoML file.yaml. So the moment you do the BentoML build, it reads through the BentoML file.yaml. And the BentoML file.yaml specifies the service name, specifies which folders are to be included and which files are to be included, all of this. Now, for the Python, which is the requirements.txt, and for the Docker, um, uh, what is um, what is the OS that it should be using all of this. So the objective of BentoML build is to read through the bentoml.yaml, gathers the Python code, gathers the weights of the model, and along with any other dependencies, and packages them into a standard bento format. And that is what's happening here. And the next one, BentoML containerize LLM inference latest platform Linux slash AMD64. So the idea here is that, see, we created the bento in the previous step. I take that bento and then wrap it inside a Docker container image. Now, the platform flag here The platform flag here ensures that this image is compatible with the standard AWS uh, cloud servers that we have. Now, coming to the next part, which is a physical registry. So we talked about the model packaging as well with BentoML. Where are the list of steps, by the way? This one with BentoML. Yes. So we did the part up to containerizing the LLM inference, and it says that successfully built the bento container for LLM inference latest with the tag so and so. So it means that if you need to access the particular version of this, then you need to use the LLM inference colon whatever the uh, unique identifier is. Now, okay, so the containerization is done. Um, okay, perfect. Now here, we are just printing the AWS account ID because we have a reason. And using the account ID, it returns the account ID here. And using the account ID, just replace the account ID with, sorry, replace this with account ID and then run this part. Now what happens here is, this one is responsible to fetch a temporary security token from AWS and passing it directly to the local Docker client so that the Docker is now authorized to upload files to your private AWS account. So here, this is more like an authorization that we're doing here. Now, here we are taking the user account ID and we have written a script to load the user account ID to this variable. Now, post that. Once the user account ID is created, what we are going to do is we are going to tag the LLM here. That means we are going to rename the local Docker image to match the exact URL format that is required by AWS ECR. So AWS ECR requires a certain URL format that ends with this, and you can change the AWS ID and you're free. You're good to go. So it takes the LLM inference colon whatever tag it is. It takes that LLM and then it gives them in this format. Right. Now, did we miss something? Uh, yeah, the AWS ECR create repository. So we are just creating a new empty storage folder in AWS ECR to hold the LLM inference images that we get. No. Okay. Yeah, then the doctor pushes as well. So here, wait, did we cut through it? Yeah, this one. So here what happens is it takes the heavy Docker image and uploads it to AWS ECR that we had created. That is what it does. So it pushes whatever Docker file that we created into the AWS ECR. Now, this is where the deployment part starts from. Setting up was until now. Now the deployment part starts from here, starting with the first command, the Helm upgrade. So the Kubernetes YAML files that we have, all of them, the YAML templates of Kubernetes, they are in the K8s folder. And it reads the YAML files, the Helm reads the Kubernetes YAML files that we have, and then deploys them to the cluster. And if the YAML files do not exist, it installs them. And if during the installation, it also upgrades them. So this is what happens in the Helm upgrade part. Now, after that, we have to modify the Kubernetes deployment configuration. And the Kubernetes deployment configuration should be modified such that we have the new URL image pushed to the ECR. So we need to um, use the new URL image, which is why this was modified. Okay. Now, okay, kubectl set image. And this one forces Kubernetes to terminate any old containers and spin up new ones using the uploaded image that we just set. Now, that is the rollout, restart, all of this. Then finally, this one opens a secure tunnel between the port 8080 on the local computer that we have here, and also the port 80 on the Kubernetes service, which runs in AWS. So from a testing and observability part, you could just run something like this and it's gonna give you, or it's gonna show you how it is working. It's gonna show you the response and everything. And you can just log into, you can follow these steps in order to set up uh, the observability as well. And you can go into this URL and you can see the graphs for yourself. Now, this is about the production deployment. You just have to follow the steps one by one and you'll be good to go. And I was telling you that not just the production deployment, I can also show you the local deployment part, right? The local deployment, I just need to follow a few steps. But before that, any questions on the production deployment part? Any questions on what each components are? Any questions on how they work with each other? Anything here? Please feel free to ask. So I see some questions in the chat. Can the links be shared again? You cannot run a standard EKS cluster completely for free, and trying to autoscale worker nodes will quickly trigger charges. Yes. Um, yeah, Abhinav, thank you for taking those questions. Yes, you have, when you register for AWS, the first time you register for it, you get free credits of up to $100. So you can utilize up to that. But please make sure that you do not use the M5X large, because M5X large, you cannot use the with the free tier, but rather you will need to use something instead, like for example, the T3 medium or the T3 small, whichever is available. So these are just names of the different node types in AWS. You can just Google it, you will be able to find it. Now, uh, okay, perfect. Now, what else? Now, coming to the local deployment. It's the same as that of the production deployment, just that it will be deploying in your local machine. Production deployment deployed it in AWS. Local deployment is going to deploy it in your local. But the small difference is that in local deployment, we can also take a look at the UI if everything works as expected. Uh, this one, the local deployment here with the UI. Where is it? Ah. So first, I need to stop the production deployment in that case. Yeah. Okay. Let me just activate the virtual environment. LSLA. And this is the name of the environment. Source will activate, and the environment gets activated. The requirements are already installed inside this environment. It's fine. Let's try running it. Ah, 1 1. One moment. Bento, bento, not bento. If you're attempting to import bento, oh, wait. Let's see. Yep. So it is listening on this spot. Now the next step is let's just test it with a prompt. The generate a endpoint is what we use for testing. Wait, no active processes on the server. Uh, wait. There is some path issue that I've given. Mm, One moment. It's fine. I just wanted to show you a basic UI for this. That's all. Let me just fix that. Give me one moment. Mm, This was the optional front end that I wanted to show you because I showed you the production part. It's just a, local one I wanted to show. Give me one moment. Let me just fix that. Give me 2 minutes, okay? I'll just fix that and be back. I require to change some local paths, which is why I stopped the sharing. Just 2 more minutes. The issue happened because my folder consisted of spaces and the code was not taking the complete folder path. So, which was the issue that we faced earlier. And once we get the uh, Pentagon server, just fixing that in a moment. I'll just take 2 more minutes. If it still doesn't get fixed, it's fine. We'll go with the production part itself. Um,
Folks, till the time Justin is fixing that, I'm gonna launch the third poll of the day where you can just tell us how, if you were with us for the 2 days, how was it? Uh, and what did you like about the session? So go ahead, do that poll till the time Justin is fixing it.
I think I figured out the issue. I think the issue was that we were using the port 3000, and the port 3000 I already used yesterday for Prometheus for the UI part. So now when I'm trying to launch the local application in the same port, I'm unable to do that. So yeah, one moment. I'm just bringing up the UI in a moment. All right, got sorted. Yeah. Yep. Let's check. Oh, what? Okay, anyway, I'll show you what happened. So what happened was that, oh, Earlier, I used the port 3000 as per the repo here. But yesterday, I had used the same port for the Prometheus one. So that port is still occupied by Prometheus. So which was why it was not working. So this time, I need to run it on the port 3000, a different port. So I chose a different port, like 3001, and I'm able to run it. Yeah. So it is running on 3001, and this time, oh, wait. I am trying to trigger it using the input hello, how are you on 3001, and it is able to provide me the response. I'm okay by the model dialog GPT medium. And then I just so one moment. Mm, source VN activate. I'm activating the environment, then let's see whether the front end will work as expected. I'm not sure. Then cd front end. Let me just install the required packages for the front end, which we already have. Okay, so it's asking me to go to 3030. Localhost 3030. Let's see if it will work. The front end is this. So just wanted to show you guys the front end. Even if it doesn't work, it's fine. I'm just showing you the front end, how it looks like. We have created a basic front end. And in this basic front end, you can give the prompt and it should give you the response. Let's see whether it will work. Hi, how are you? It's throwing some error with respect to the um, front end, I think, because we were able to trigger it. Okay, I think what happened is um, this 3001 port change that we made, that port change has not been made inside the front end code. So the front end is trying to access the port 3000, which was what we had earlier. So if we go there and make that change as well, then it'll be fine. So it's fine. When you're running it for the first time, these issues won't happen because your 3000 is not occupied by Prometheus. So don't worry about that. You will be able to run it properly. So the primary objective of this is I wanted to show you this front end. But the main objective of today's session was I wanted to show you how the production system works, how each of these components works hand in hand, and also what are the components that we used. And I also wanted to show you how the uh, graphs look like, or the observability matrices looks observability part looks like. So you can change whatever you want to see. You could go to explore and you could make the change to whatever metric you wanted to see, and it would have populated that metric as well, like the number of requests that are coming in, etc. So if you want to productionize it, the only challenge that you might face is the M5X large. If you're using the what do you say? If you're using the free version of the AWS, or if you're using the paid version of AWS, it's fine. You can go with this, no issues. You might have to change this to T3.small or T3.medium, whichever your free tier gives you, or whichever your free tier is fine with giving you. So this is what you should be doing to productionize it. So you have the complete code base along with the front end and along with everything, every instruction. And if you want to productionize, just follow these steps and you will be able to productionize this end to end. All right. Okay. Do you have any questions? I wanted to take your questions. So deploying via an agent running inside the very cluster you're trying to update is a massive, well-known challenge. Deploying via an agent running inside the very cluster you're trying to update. I don't think I tried that. Krishnan, by the way, I don't think I tried that. How we deployed in production? Yeah, that is exactly this. You just follow these steps and you will be able to deploy it in production. So you are containerizing using BentoML, and you are deploying it in production by setting up your EKS clusters, and then you are tagging that Docker. So you will have to install Docker in your system, and then you Dockerize it, and that Docker in your system, you're tagging it to AWS. And in other words, you can think of it as uploading there, and then they're going to in AWS, you will be using it to run it in your EC2 instances. So that is what you're deploying. That is how you're deploying it in production. So just follow the steps until here. Your deployment would be done, and you are also setting up your Prometheus and Grafana for visualization as well. Right. I see some questions in the Q&A. Can't we kill all the processes which are using the 3000 port? Yes, we can do that. But I just wanted to continue working on the production part after this, which is why I didn't want to kill everything, because then I'll have to do all of this once again, which is setting up the 3000 part. So the only difference that it's going to make is you will see the response of what you saw, the same response here that you're seeing. One moment. The same response that you're seeing here. What's that? Saying that when I provided the input as how are you, it provided the output as I'm fine. That same response you will be seeing here. That's all. That's the only difference that's going to make. So I'm going to give more importance to the production deployment. So which is why I spent a lot of time yesterday spinning up all of these instances and creating this document for you to use as well. So before we close this session, let me just share this with you once again, because uh, if you go with the README file directly for production, I faced a few issues, glitches here and there. So I fixed all of that, and that is what you have in this document here. Yeah, this production side is a pain in the neck. Yeah, it is. Yeah, it's a bit. Yeah, I wouldn't disagree with you there. All right. Does the shared documents of front end codes as well? Yes, it does. So here, this one. Yes, please do try it out yourself, because see, I would love to try it out alongside you right now. But like I told you, if you want to just spin up the EKS, for instance, I have to wait like 20 minutes for it to finish building. So we can't afford that here, right? I mean, we would just be waiting, doing nothing else. So, all right.
Yep. I think we have covered most of the questions, and Abhinav again obviously came through and has answered everything in the chat. Uh, I think it was actually good to see you trying to debug what you came across, Justin, because that's very real, right? People are going to face such kind of issues, and how do you sort of think through was also sort of on
Yeah.
display today.
Another takeaway is that I need to edit the code in such a way that the local deployment as well as the Prometheus does not use the same
Same,
endpoint,
yeah.
so that you won't be facing that issue. So I'll mostly make this change today itself. Let's see. Yeah,
Awesome.
in the
Awesome.
README. Yeah.
That is helpful. Folks, I think Justin has given all the resources and material that he used, all the links that he possibly had to share. The recording of this session, because a lot of you wanted to follow along, but like Justin said, it's not possible. We would have had a wait time of 30 minutes, which we cannot afford to do. We don't want to eat up into your Sunday more than what we already have. Hopefully, it is something that you would value in terms of all the concepts that Justin and Parijat covered today. But go ahead, go to our YouTube channel, I interview Kickstart India, and go to the live section, and the recording of the session would be available by tomorrow. Okay, so you can follow along, go through it at your pace, and yeah, but try it out yourself. I have also, I think everybody had answered the poll, so I've ended the poll also. If there are no more questions to be asked, we can conclude the session for today. I'll just wait for about 30 seconds if somebody has a question. Cool. Thanks, Viraj. I think after
That's
deployment.
my question. After deployment, what can we do? After deployment, the whole purpose was a deployment here, which was just to show how you can take an LLM that you have and deploy it on production so that you will be able to utilize that endpoint, or others will also be able to utilize that endpoint in order to access that LLM. And then if it is an LLM, then they can ask questions and get the answers. That is what it does, just like your old version of ChatGPT. But if you're building an agentic system, then you will have further capabilities. Like, for example, um, if you're building an agentic system um, that does something for you, that books your flights for you, books your hotels for you, or something like that, then you can utilize that to get that done. But this is just an LLM, text in, text out. So the objective of productionizing it is that you and me, whoever else has the endpoint will be able to utilize it, unlike your local deployment. Yeah.
Awesome.
And yeah, sorry, please.
No,
That's
no,
it.
go ahead, Justin. Please go ahead.
No, that's it. That's it. Yeah.
Cool. Okay. Yes, Amit, you can go through the YouTube link, and thanks for the compliments. Or Justin, that's all you, and Parijat. Thanks a ton, people, for joining in. Have a great Sunday. It's 3:16. We still have some time left to go and enjoy with our families. Please go ahead and keep upskilling, keep joining us for these sessions. And if you want to know more about our programs, like we have shared the link before, our program advisors will anyway get in touch with you. If it's relevant, do check that out too. Okay. Thank you. Thank you so much, Justin. Take care.
Thanks, everybody. Thanks for your
Thanks,
time.
Abhinav.